this session, this fun session in English sort of language. So ऐसा नहीं होगा. It won't happen कि you will not understand the terminology and the code part which I'm writing and the conceptual part. You will understand it. Okay. I can do full English as well, but there are a lot of students who will be unable to understand everything in full English, I think. So English is perfect. ठीक है. हाँ, फन वे में हम आपको पढ़ाने वाले हैं. ओके. ऑल राइट. जस्ट अ सेकेंड. हेलो 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 हेलो. यस, आई एम स्टार्टिंग द लेक्चर. सबसे आई एम एट माई होम. दैट इज माई वाईफाई राउटर. उधर आई एम शेयरिंग अ स्क्रीन. ठीक है, जस्ट लेट मी नो इन द चैट कि द स्क्रीन इज विजिबल टू यू और नॉट. ओके.
एक्चुअली आई एम स्ट्रीट फोटोग्राफर. मैं ना रैंडम लोगों की फोटोज क्लिक करता हूँ. को व्हाट्सएप कर लीजिए, कर लीजिए फोटो. नहीं नहीं, फोटोज तो मैंने ले ली है. आप एक बार देख लीजिए. देखिए. अच्छा, दिखाइए दिखाइए दिखाइए.
कैन यू प्लीज स्टॉप टेकिंग फोटोज?
ये नंबर, एक मिनट रुकिए. आपके पापा का नंबर भी है हमारे पास. तो ये हमारा पेटीएम बारकोड है. 25,000 रुपये इस पे पेटीएम कर दीजिए. गुड इवनिंग सर. 20 में नहीं होगा क्या? गुड इवनिंग सर.
Good evening, everyone. Please give me 1 minute. I'm really sorry for all the behavior of these students.
म्यूट कर दो सर, जिसकी आवाज आ रही है.
हाँ सर, सब लोगों को म्यूट कर दो
It
एक
is
साथ.
not possible for. Just give me 1 second if I can mute everyone. Okay, so everyone is now muted. Good to go. ठीक है, just give me 1 second. I'm attaching the writing screen. This way I will teach you everything. All right. Now please let me know in the chat section. कहाँ गई चैट भाई? चले गई क्या? ये रही. ठीक है. कैन यू सी दिस एंटायर बाइनरी ट्रीज? ये नजर आ रहा है ऐसे करके? ऐसे, ऐसे. राइटिंग थोड़ी सुधार लेते हैं हम अपनी ना, हल्की सी. परफेक्ट बना लेते हैं. ठीक है. ऑल राइट. ऑल राइट. ऑल राइट. अरे ये फिर मेरा चेहरा इधर आ गया. पहले मैं इधर लाया था. हम्म. ठीक है. ओके, आई विल टीच इन इंग्लिश. तो एक्चुअली ऑल द कॉन्सेप्ट्स from me are going to be in English only. So do not worry about any sort of conceptual thing. Oh, what is this actually? Because ये मेरे इसमें नहीं आ रहा है. Anyways, can you see this orange line or something? It is disturbing. It's very disturbing. Yeah, let me just get it. Whoever is doing this, please do not. Sunil and whoever is, please let me teach. Just give me 1 second. Uh, तब से अनम्यूट दबा। अब हुआ, थैंक यू वेरी मच। सॉरी गाइस, एम आई ऑडिबल? प्लीज टेल मी। आई एम रियली सॉरी। आई डोंट नो व्हाट काइंड ऑफ प्लेटफॉर्म इज जूम। इट्स वेरी बैड, बट एनीवेज हमारा काम इसी से बनेगा। ठीक है, तो लेट मी स्टार्ट द लेक्चर। सबसे पहले एक छोटा सा इंट्रोडक्शन दे देता हूँ, इफ यू डू नॉट नो मी हु आई एम। ठीक है, तो आई एम एन एक्स सॉफ्टवेयर इंजीनियर एट पेटीएम। ओ, पेटीएम की स्पेलिंग भी गलत लिख रहा हूँ, बड़ी गंदी बात है तो। ऑल राइट, so I know about data structures and algorithms, and I have been teaching DSA for the past 2.5 to 3 years now. All right, so can you help DSA and Python language? I will use first of all Java language today, but even if you are coding in C++ or Python, you will be able to understand all the things. ऐसा नहीं है कि you won't be able to understand, because the concept of the node class and the recursion will be exactly same. ठीक है, and anyways you guys are smart enough to use ChatGPT for your own convenience as well, right? So first start, before starting I would say कि prerequisites में you should know a thing or two about linked list. So if you do not know what a linked list is, if you are uncomfortable to just traverse on a linked list का मतलब है ट्रैवल करना, उस पर प्रिंट कराना एलिमेंट्स को, या बेसिक जो आपका नोड क्लास बनता है, इफ यू आर अनअवेयर ऑफ दैट, then understanding binary trees today will be very, very difficult. So please go and study linked list first, very basics of linked list, not advanced linked list. Okay, if you know that, it's very easy. First, let us start with basics, terminology and implementation. But first, linked list और इसका comparison देखते हैं। ठीक है, so what happens in linked list? हाँ, C++ is also same. There is no difference in Java and C++. There is a difference of this arrow thing. I'll tell you. Not a big deal. ठीक है. So in linked list, we all know that we have a head node, right? We have a head node. Head node. We have a node basically. It is a collection of nodes. Now see it very, very carefully ताकि आप लोगों को परेशानी ना हो. Basically what happens is, in a single node it contains value of खुद का, अपना खुद का value, its own value, which is for example 10, 20, 30, 40, 50, or whatever it is. It can be anything. And it contains the address of the next node in the linked list. So please understand what are these arrows. These arrows actually represent कि भाई 10 है यहाँ पे, तो 10 के आगे आता है 20. So 10 has its own value which is 10, and address of this 20 node, so that we can traverse to 20. So technically this 10, for example, this node is A, B, C, D, E. So I will say that A dot value is equal to 10. A's own value is 10, but A's next is equal to B. Similarly, B is next is C and all. अब बाइनरी ट्रीज में क्या डिफरेंस होता है? लेट्स टॉक अबाउट द डिफरेंस इन बाइनरी ट्रीज. ठीक है, सो बाइनरी ट्रीज इज वेरी, वेरी सिंपल. I will talk about the entire terminology, but please make sure of some things. ठीक है, a few things to make sure. ठीक है, अगर आप भी उन्हीं बच्चों में से हो, if you are one of those kids who just study binary tree for the terminology, let's say for example, we all know that this is a tree. If you don't know, I will tell, but a lot of students know that this kind of a structure is in computers, it is a tree structure. Okay, now this is a binary tree because of something that I will tell, but in general, in a tree structure, I see that most of the students are concerned about कि okay, this is the root node. This is the root node. These are the leaf nodes, right? It is the parent of this node and this node. These two are child nodes of these two nodes. These two are child nodes of these two nodes, and all of these things. Now, this terminology is important, but it is very simple and it can be learned in 5 minutes, which I'm going to eventually tell you. But the thing is, यू हैव टू मेक श्योर कि आप पूरी जिंदगी यार ये ना करते रह जाओ। मैंने ऐसे बहुत सारे कॉलेज के स्टूडेंट्स देखे, आई हैव सीन अ लॉट ऑफ कॉलेज स्टूडेंट्स who never study data structure algorithm, who just cry when their placements come, and they say that okay, this teacher did not teach us well, or something, things like these, which are absolute bullshit. So you have to please understand, you do not have to cry. You have to learn how to implement a node of tree in your language, C++, Java, or Python, or whatever, and then solve questions on trees. Questions on trees. And it only happens, ये सिर्फ तब होता है when you are able to traverse the tree, when you know basic recursion. If you don't know what recursion is, if you are unfamiliar with recursion, uncomfortable with even the basics of recursion में we have a lot of things like कॉल से पहले काम, कॉल से पहले काम, कॉल के बाद काम. In English, I would like to say that, okay, if I'm calling a function from a function and the function is something like this function, and then I call it again. So whatever I do over here, work one, and I can do something after the call. So this is work before call, this is work after call. So you have to understand, if you are calling any sort of recursive function like this, what happens if I have written a statement over here? What happens if I have written a statement over here? When will this statement get executed? These all things are in very, very basics of recursion that can be understood in less than an hour. So you have to understand these things first, then only you will truly able to understand trees. तो चैट में प्लीज लिख दो कि आपको ये बात समझ मेरी आई या मेरी बात ये समझ नहीं आई, क्योंकि कुछ 10 से 20 बच्चे डर के भाग चुके हैं अभी से, क्योंकि वो उन्हीं बच्चों में से थे who are there to learn about root nodes, sibling nodes, child nodes, leaf nodes, right? So please tell me in the chat. So a lot of students are saying English only. So speaker, please kind of understand that everything that I'm teaching is in English only, right? If you hate Hindi language, it's not a good thing, first of all. But for all the Hindi based audience, at least I'm trying to communicate with them, and I'm also translating it in English at the same time. So please be patient. A lot of students are here who can only understand Hindi. Some students can only understand English. I'm talking in both of the languages. मैं दोनों भाषाओं में बात कर रहा हूँ ताकि सबको सब कुछ समझ आ जाए. ठीक है? Yes. आ जाते हैं. Time duration will be यार, the current time is 8:18. So I'll take till 10 p.m. or even more. It totally depends on your dedication. If you want, I'll stretch it. Okay? Okay? Yeah. I will focus on learning the topics. Thank you. Thank you, Ankit. All right. So first of all, let's talk about again the basics compared to linked list and trees. So what happens in trees, in linked list, if you have a node, इसकी खुद की एक वैल्यू है, it has its own value, and it is connected to some other node, right? It is only connected to one node. It is only connected to one node. One node is only connected to one node. It has one next. The node is next, right? So in trees, in binary trees, in trees in general, I would say it can have like it, for example, this is a node. Again, it has a value, let's say 10. So it has multiple nexts. इसको इस तरीके से देखो that it has multiple next node. So a single node can actually be connected to a lot of nodes. One common thing in linked list and trees is that technically there is no such two-way connection. मतलब there is in doubly linked list, if this is connected to this node is also connected to this node via a previous link. But in regular linked list, it is not the case. Similar to that, in trees, it is not the case like, for example, 10 is connected to this node, which is called its children also, right? It is a parent. So a parent has multiple children. So also these nodes are known as, isko ratna nahi hai, you do not have to mug it up. Just feel this thing that if there is a parent node, it has two or more or even one or zero amount of child nodes. So these nodes are absolutely similar to linked list. Now the difference in code is something like this. What we will study today is binary trees. What? Binary trees. So what happens in binary trees is that a single node can have at most two children. एक नोड के दो ही बच्चे हो सकते हैं एट मैक्स. एट मैक्स का मतलब क्या होता है? एट मोस्ट का मतलब क्या होता है? व्हाट इज द मीनिंग ऑफ एट मोस्ट? इट मीन्स दैट a node can have zero child nodes, one child node, or maybe two child nodes. So technically it is written as something like this. So for example, this is a node. It has some value, I will say 20 or maybe 21, right? So this node is known as the left of this node. Okay, for example, the values are 30 and 40. What I'm trying to say is this node is the left of this node. So left child node. Now this is right child node, right? Left child node, right child node. Also I know मैं बहुत प्यार से अभी धीरे धीरे करके पढ़ा रहा हूँ. Please trust me, there are a lot of students who do not know a thing about it. That's why I'm teaching from the very basics. So be patient. ठीक है? So this is binary tree. Now we will focus on linked list and binary trees for a moment. The code is something like this. We know that in linked list, when we make class node, you have to know what a linked list is. Okay, only then you will truly understand the things and binary trees. So class node, first of all, it has its own value. It can be val or it can be data also. In Geeks for Geeks practice platform, it is data. So it can be val, and this has a next pointer as well. In C++, there is a star. In Java, there is not a star. There are no pointers. So this is what? This is a node. We can make constructors as well. बाद में देखेंगे हम. But this is a node in linked list. Similar to this, a node in binary tree is very, very similar. It has its own value and it has two nexts. Two nexts. So the names of the nexts are left and right. They are left and right. So the code of both these things are very, very similar to each other. That is why I said ki learning basics of linked lists gives a huge boost in terms of learning binary trees. Also, in interviews, binary trees is technically generally the most famous and the most usually क्या होता है interviewer जो होते हैं, for example in Amazon and big companies, so they love binary trees. And there can be a lot of questions that can be framed from binary trees. That is the reason, and it is very, very easy. Okay, it is much easier than learning dynamic programming and things like that, right? So some students are saying it's binary search tree. In binary tree, left child is smaller and right child is bigger. No, it is not like that. In a normal binary tree, there can be any value. Okay. In binary search trees, there is a particular property that I will tell you later on, tomorrow or maybe day after tomorrow. Today it will be totally based on binary trees only. Yes, the recording will be available on YouTube, but I am not sure कि they will keep the recording because it is supposed to be a live class. So if you have to be disciplined to attend this live class completely, पूरी live class को attend करो, डिसिप्लिन तरीके से रहो. ठीक है, आ जाते हैं. चलो ट्रीज हमें समझ आ गया. अब थोड़ी सी वी शुड अंडरस्टैंड द लेट मी मेक सम ट्रीज फर्स्ट. लेट मी मेक सम ट्रीज. So, binary trees are something like this. A child has two children. But you can ask me that, sir, in these four nodes, in चार nodes में, they do not have any children of their own. Yes. So just like in linked list, whenever the last or tail node came, tail's next was null node. It was null. Null is nothing, right? Similarly, technically, the child left and right child nodes of these four nodes are null. And null has no left, no right, no next, nothing. It does not have its own value. ठीक है, खुद की वैल्यू तक नहीं है नल की, कोई औकात नहीं है इन शॉर्ट. ठीक है, नल हैज नो औकात. ठीक है, इट हैज अ लॉट ऑफ औकात बट स्टिल हम बाद में डिस्कस करेंगे उसको. अब आ जाते हैं, दिस इज अ बाइनरी ट्री. नाउ दिस कैन ऑल्सो बी अ बाइनरी ट्री वेर इन, फॉर एग्जाम्पल, दिस हैज वन लेफ्ट node, it has one right node as well. Now this only has a right node, and now this has a left node and a right node. So as you can see, there is no left node of this node. So it is a null node. There is no left and right of this. So technically there is, it will be null. There is no left and right for this and this. So if we just ignore the null node, we can clearly see this particular shape is also a binary tree. This is also a binary tree, right? In this binary tree, binary trees and binary trees, it is not mandatory for every node to have two child nodes. Like it has 0, it has 1, it has 2 again. So this can happen 0 or 1 or 2. Now let's talk about some terminologies on trees. वो भी important है. So the topmost thing of a tree, basically, अच्छा, a lot of students must be thinking ki why this kind of data structure is known as a tree. So the shape is like a tree. The roots of a tree, in fact, I would say roots are like this. And if you just invert it or in opposite sense, so it kind of becomes like a tree with a root node and the branches, right? So this is known as the root node. And all of these nodes are known as leaf nodes. Basically, leaf node is not like ki it has to be the node on the lowest level. I'll talk about levels also, but the lowest level. No, this is also a leaf node. A leaf node is basically that node which has no left and no right. उसका कोई लेफ्ट नहीं है, उसका कोई राइट नहीं है. वो हो जाएगा हमारा यार लीफ नोड. यहाँ पे कितना बढ़िया बात हो गई यार. तो ये भी एक लीफ नोड है, ये भी एक लीफ नोड है, एल लिख रहा हूँ मैं यहाँ पे, ये भी एक लीफ नोड है, ये भी एक लीफ नोड है. And now let's talk about the children and the parent nodes. So this concept is relative. Matlab, it means that, okay, if we are talking about this node, then these two nodes are the child nodes of this node. Now this can also be a child node to this node. This node is parent of these two nodes. This is parent of these two nodes. This is parent of these two nodes. There is also a concept of ancestors. Now, ancestors, Hindi mein, it means Purvaj, right? So, for example, my grandfather is my ancestor. My great grandfather is also my ancestor. Technically speaking, my father also comes in my ancestor line, right? So, all the ancestors, for example, this is the node. So, for this particular node, I am highlighting this node. This and this, these both are ancestors of this. Now, keep in mind, this is not the ancestor of this node. So, for example, if you are this, नाम ले लेते हैं किसी का आयुष, ठीक है? If he is Ayush and he is Ayush's father, now obviously he is Ayush's grandfather, let's say, and he is Ayush's Tauji, ठीक है? So Tauji is not under his ancestors. Please understand this thing. Technically, he is a part of your family, but that is a complete tree. But I would say he is not your ancestor. Keep in mind. ठीक है, तो यही हमारी these are the terminologies involved in trees, nothing else. Now let's code. एक बार chat में please write कि code करे या नहीं करे. Let's code and let's make some nodes and then connect them and make a tree. And then we will try to traverse in the tree and try to print the tree. Okay. So Kirtana, what are the main difference between binary search tree and binary tree? I would just suggest you to be patient and wait for the next lecture, which is going to happen tomorrow, or maybe even the next lecture, which is going to happen on Monday. Okay, so I will talk about BST, the binary search tree, in very detailed manner. Okay. And again, the concern of you guys should never be what is the difference between this tree and that tree. It does not matter. In interview, no one is going to ask you what are the differences between the trees. The interviewer will straight away ask you a question of binary search tree, not even telling you that it is a question of binary search tree. That also you have to identify. Okay, so I will talk about all these things. And what are the applications of binary tree? So technically it is a hierarchical based data structures, Gaurav, but I will tell the applications in binary search tree, right? Technically speaking, it has its applications which are very interesting. I will tell you all about it. Okay. Can you code with diagram base? What is diagram base? Okay, I'm opening up IntelliJ IDEA for you guys to understand a lot of things. And let me just tell you what I'm going to, just a second. Java programming. All right. So in code, first of all, I'll show you how to create a node. Second of all, I'll show you how to print. I'll show you the connections, how to connect the nodes with the diagram. मतलब I'll make a diagram and then connect it. ठीक है. Third, I'll tell you how to print it via recursion. Now this is the most important step because इस step के अंदर you guys will understand what is recursion and what is a binary tree in reality. ठीक है. No, I can't code in every single language. Okay. So please do not move away from the class. It is your choice, but again, I have to code in one language only. It is physically not possible for me. You will get the codes for all the languages. I'll make sure that the GFG team uploads every single code that I'm writing in Java, and then they will convert this code into CPP and Python and send the codes to you. ठीक है? Please tell me in the chats if you are unable to understand English for some reason. Some students are. Okay. So I'll just close this thing. I'll share a screen. Please tell me if you are able to see my screen in just 1, 2 and 3. ओके. ठीक है. तो ये यार हमारा इंटेलिजे आइडिया ओपन हो चुका है. दिस इज इंटेलिजे आइडिया. इंटेलिजे आइडिया. ओके. इंटेलिजे आइडिया. This is a ID for Java. All right. So I'll open up trees. I have already opened up trees. Let me make a folder for you guys. ठीक है. Let me make a folder for you guys. जिसमें I'll only trees geeks for geeks. And I'll make a file. Basics. Nodes.java. ठीक है. तो the C++ code is very much similar. There is not much difference. So in C++, this PSVM, public static void main, is actually int main. Okay, so C++ mein we write int main and there is no bullshit like this. Anyways, so we make the class outside here, or maybe we can make it here, but I'll make the class here. So I'll make a class node, like a capital N. So then the node can be accessed to every single file of this thing. Anyways, you do not have to worry about it. So what happens in linked list? I said it has a value val and a node next. Here there is left and right. एक second bus, left and right, and you have a data type. So what happens is, if you do not know object-oriented programming, then do not watch this lecture. It will be very difficult for you to understand anything. But in short, if I tell, if we write int or float or char, so these are data types. Now node is also a data type that we personally created. ठीक है. तो हमने खुद बनाया है data type. So what I'll make is, first of all, I'll share a screen again, and I'll make a tree, draw a tree, and then we will make it. अरे दिख जा, कहाँ गया? Cool. ठीक है. तो I'll make a tree. The tree is something like this. इसके भी दो बच्चे हैं, इसके भी दो बच्चे हैं, इसके भी दो बच्चे हैं, इसके भी दो बच्चे हैं. And the values are 10, 20, 30, 40, 50, 60, and 70. Let's say कोई भी, you can give any value. ठीक है. So I have to make this tree. I'm also naming the nodes as A, B, C for your convenience. Please इसको ढंग से देखना है बच्चों यार, प्लीज. ठीक है. थोड़ा ढंग से देखना. बोरिंग टॉपिक हो सकता है, बट थोड़ा अंडरस्टैंड करना है हमें कि क्या चल रहा है यहाँ मामला. So this is the entire tree. So as we can see, this is the root node. So let us make 7 nodes first of all. And let's put the values at 10, 20, 30, 40, 50, 60, 70. Yeah. So let's go to the code part again. Let me share the screen. I know it is hectic. Again and again, I'm sharing the screen. The screen will be visible. So what I'm trying to say is I'll create 7 nodes. Node A, B, C, D, E, F. There were 7 nodes. So node A, I created node A. Now I will also give the value. I give the value here only. A की value, a dot val, we use the dot operator, and in C++ we will use something like this. ठीक है? So a dot val we will give as 10. Now what is happening? What is the problem? Achha, we have to initialize in Java also. I have not taught constructors to you. Anyways, so what we will do is, ठीक है, we'll make some constructors as well. ठीक है, this is known as a constructor. Okay, this is a default constructor. This is a default constructor. I don't think we have to initialize this as well. Okay, we have to. So let me teach you constructors as well, because it is very important to just understand the concept. So in linked list, I hope you guys have already studied linked list, and in linked list there are constructors, so it makes our work 10 times easier. So for example, we have to create a node A with value 10. If we want a variable int a is equal to 10, we can clearly give it 10, right? It is very simple. So constructor is very similar. What we will do is we will give a value. We will give a value, and this dot val is equal to val. So अभी के लिए just मग दिस थिंग अप, इसको रट लो। अगर आपको कंस्ट्रक्टर नहीं आता, आई वुड से प्लीज कंस्ट्रक्टर पढ़ के आ जाओ। व्हाट हैपेंस इज इफ आई गिव नोड ए इज इक्वल टू, प्लीज, इज इक्वल टू न्यू node, and if I give the value 10, so what happens is a node is created, a ball is created, circle a with value equal to 10. Now we will create 6 more nodes. So in coding we never type again and again, we just copy and paste. ठीक है, क्या हो रहा है यार, ये ऐसे क्यों हो रहा है? ठीक है, so this is node B, this is node C, this is node D, and अरे यार ठीक है ना यार, क्यों हो रहा है ये? ठीक है, this is node E. So IntelliJ IDEA is a very bad software sometimes. Anyways, it gives auto suggestions and all that, all those things. So this is 20, this is 30, it has value 40, it has value 50, it has value 60, it has value 70. ठीक है, तो I have 7 nodes in total. I have 7 nodes in total. Now comes the connecting part. एक बार let's go again to the diagram. Please note these things, or at least have a clear picture in your head. ठीक है, let's come on to the screen. The screen might be visible to you now. ठीक है, now this was the tree. This was the tree. हटो ना, this was the tree. This is A, B, C, D, E, F, G, H. What I have done currently is something like this. Let me remove these connections. These are known as connections. So what I did is I created 7 nodes, but they are randomly hovering, I don't know where. Okay. Now I have to connect them in such a way that A is the BAP of every node. It is the root node. So A's left should be B, A's right should be C. I would say A dot left is equal to B, A dot right is equal to C. Okay, I am writing it here also. A left equal to B, A dot right equal to C. After writing these two statements, this happens. I will write B dot left is equal to D, B dot right is E, C dot left is F, C dot right is G. These are the connections. Now let me actually connect in code. It is very, very simple. It is very, very simple. Very straightforward. We created all the nodes. Now we will what? थोड़ा सुंदर करके कमेंट कर देते हैं, सॉरी, कनेक्ट कर देते हैं। ठीक है, कमेंट करके। सो दिस इज नोन एज अ कमेंट, आई थिंक एवरीवन नोस। एनीवेज, इधर आ जाते हैं। सो वी विल कनेक्ट द नोड्स नाउ। सो ए डॉट लेफ्ट वाज व्हाट? ए बी सी। सो ए डॉट लेफ्ट इज बी, ए डॉट राइट इज इक्वल टू सी। ठीक है, similarly, now B dot left was A, B, C, D, E. So B dot left was D and B dot right was E. And then C dot left was F, C dot right was G. Now you might be wondering that okay, A has left and right, B has left and right, C has left and right. What about D, E, F, and G? What are the left and right? So by default, every nodes, for example, I never made these connections. So actually, what was the scene? That in all these nodes, the left and right are initially null. They are initially null. Okay. Now let me connect also. Okay, I have connected these nodes. So this is the tree. So after doing all these 7 things, all these statements, the tree is finally formed. Okay. Tell me in the chat if you are able to understand. And for all the Hindi users, I am really, really sorry because thoda sa, there is a lack of energy from my side because I am actually translating every single thing inside my head first, then communicating with you guys and talking in English. So it is a load for me. Okay. सर इसमें पॉइंटर नहीं स्टोर होता next node ka. So Arjun, what happens is in Java there is no system of pointers, but in C++, if you want to understand, what actually happens is that in A's left, the node B is not stored. In Java it is stored. In C++, what happens is in A's left, only the address of B is stored. So from there we can fetch the value and the next node and the left and right of that node. Okay. So all of you can just understand it in this way. Then in that in A's left, the exact B node is not stored in C++. The node's address is being stored. Okay. काफी सारे बच्चों का वो है, क्या बोलते हैं, डाउट है. What happens if you put G children of two parents? Mistake. Oh, okay. Very, very nice question. Very nice question. So OV is asking a question. Here it is very difficult to do trees in C language. Never do data structure algorithms in C. There is absolute no support. Okay, so it is a very bad language for. Matlab it is a good language, but the thing is ki never do data structures in C. Okay, it is only feasible in your college studies where the professors are doing everything in Ghesapeta manner. So what guy is asking me, I forgot his name. An intelligent student asked me, for example, G was children. G is now children of C. What happens if I make G children of B as well? Or for example, I make G children of A. Now, obviously, a particular node can only have one left and one right. So for example, if I say a dot left, after writing a dot left b, if I write a dot left is now g. So what happens is this connection actually may breaks and a left will become g. Okay, first of all, first doubt. Second doubt is, now for example, there was, for example, no right of b. Okay, so the tree was something like this. And this is also a binary tree. There is absolutely no problem. This is a binary tree. So what happened is B has only a left child. C has left and right both. And we have 6 nodes in the tree. It is fine. Now, if I just make the right of B as F as well. So technically, can you do this? Yes, the answer is yes. We can do this. Okay, we can do this. B's right is F, B's left is D, C's left is F, and C ka right is G. But is this data structure known as tree? The answer is no. Okay, this is no more a tree. This is not a tree. This is a graph. Okay, we will study graphs much later. Yes, this is a valid data structure. But क्या ये tree है? Is this a tree? No. Because in trees, there can be no loops or something like that. This is kind of a loop. Or there, it is a very clear thing that a particular node can never be a children of two given nodes. Okay? Now, in reality, in family, we are obviously children of our mother and father both. But in binary trees, it is not the case. Okay, it is not the case. So it cannot be done. मतलब it is no longer a tree. ठीक है? Sir, a quick revision. But I am already very slow currently. A lot of students might be disappointed, but revision end में I'll do. ठीक है? Sir, instead of binary tree, if we need to connect the tree, it can have multiple child. So how can we connect that? So the thing is, this is known as a binary tree, beta. This is a binary tree. There is another thing known as a generic tree. Generic tree. So what happens in generic tree is that if you have a node, it can have any number of child nodes. For example, it has immediate 3 child nodes. Now this one has 2 child nodes. Okay. This one has only 1 child node. This has 0 child nodes. Now this particular man has 4 children. So this particular data structure is known as a generic tree, where any node can have any number of children, but again, in a tree, okay, you can sleep, Janishwan. Anyways, whatever your name is. The thing is, in a tree, a single child node can be only connected via one node. Like ऐसा उल्टा सिस्टम नहीं होता यहाँ पे कि there is a child node and it was actually children of 2 or more nodes. किसी भी ट्री में ये नहीं होता. ठीक है, this is generic tree and we are going to study binary trees, which is a simpler form to understand. Like doubly linked list, would it be possible for child to keep the pointer of their respective parents? I'm wondering if there would be any benefit of it. Yes, Kulbhushan Chopra, there are benefits of doing that. Technically speaking, yes, जैसे कि मैंने कहा, it is no longer considered as a tree, but we will do some particular problems where actually for a child node, we have to store the data of its parent so that we can go back as well. So in some particular questions, we do that. ठीक है, in some particular questions, for questions. ठीक है, that is the thing. In case of generic tree, how many container we have to declare inside the node class? So very nice question, although it will not come in your interview. It is highly unlikely. But as you can see, in a binary tree, the node was something like this, right? It has its own value, left and right. Now in generic tree, we do not know that in a generic tree, how many child nodes will be there of a single node. So it is very simple. What we do is we keep a array or a array list. For example, this is class node. Okay, so it has its own value. Any node has its own value and it has a connection. It has an array list of nodes. So in Java, it has an array list or maybe array of this node, right? In C++, there will be a vector of nodes because I don't know how many children are there. Okay? So we use array. Which language should be preferred to for DSA to crack interviews? You can use CPP or Java, anything. Even Python will work. Okay? Yes, C++ and Java, technically speaking, are kind of better than Python in the sense that whenever you are going to give, whenever you are going for an interview. So the thing is, the one who is taking the interview, in most of the cases, he has done his data structures and algorithms in C++ or Java. But the situation can change. I don't know if you are in first year or second year. So maybe when you give your interview, Python is a very popular language. But anyways, at the end of day, it does not matter. What matters is your concepts, right? If you are able to communicate the problem, even without doing the code, you will be given full marks. Okay. Yes, you can learn DSA from Java. ठीक है, चलो आ जाते हैं, अब आगे बढ़े. Please tell me in the chats if we can move ahead, move forward. This was generic tree, this was binary tree. We actually coded the binary tree. Now we have made sure how to make the node. We know how to connect the nodes, and we are going to study printing of the nodes via recursion. Now what happens is technically speaking, this is the root node. This is the root node. So the root node actually is the entire tree. मतलब ये नोड मेरे को सारे नोड्स की वैल्यू लाके दे सकता है. बिफोर प्रिंटिंग मैं आपको एक बहुत ही इंपॉर्टेंट चीज बताऊंगा विच अ लॉट ऑफ टीचर्स नेवर टेल यू. ठीक है, तो प्लीज मेक श्योर योर एंटायर अटेंशन इज इन द स्क्रीन राइट नाउ. Please understand what happens if I want to print all the values of all the nodes. I can simply print it. In C++ it is cout. In Java it is system.out. In Python it is print. ठीक है. I can simply print a dot value and it will give me the value of a. I can say b dot value, value of b. Right? Very, very, very simple. Now what I'm trying to say is something like this. For example, I want to print the value of node E. ठीक है. Node B first of all. So I will do b dot val and I will actually run this file and check b की वैल्यू क्या है 20 है ना. लेट्स चेक. ये देखो, यू कैन सी द आंसर इज कमिंग आउट टू बी 20. इट्स परफेक्ट. नाउ व्हाट इफ आई आस्क यू दैट विदाउट यूजिंग b you have to print value of b. Without using b you have to print the value of b. Yes, we can do it with a. Now if we use a, what is b? B was a ka left, b was a dot left. So when a dot left is b, what if I do something like this? A dot left dot val. And let's check what happens. You can see 20 is happening. What if I do a dot right dot val? Tell me in the chats. First tell me in the chat. So Vaishnavi is saying C, perfect. Rudrash, Rishi is also, everyone is perfect. Priya, Aryan, very good. Very nice, very nice. सब बच्चों को सब समझ आ रहा है. होशियार बच्चे हैं, समझदार बच्चे हैं, बढ़िया बच्चे हैं. ठीक है. आप देख सकते हो 30 is coming out. Now tell me in the chats, please, how can we print the value of G node with only using A? We have to print node G's value, which is 70, without using the parent of G, which is C, without using G itself, using A. Yes, Vignesh is absolutely perfect. And Arjun is also, Nancy is also perfect, Arushi is also perfect. Everyone is perfect. Aditya is perfect. Okay, so not next year. Aditya is not perfect. ठीक है. तो बेसिकली व्हाट वी विल डू इज, एक बार आपको डायग्राम दिखा देता हूँ. कुछ बच्चे ना भटक गए होंगे. सम स्टूडेंट्स माइट बी, भटकने को क्या कहते हैं इंग्लिश में? एनीवेज चैट में बता दो भटकने को क्या कहते हैं अंग्रेजी में. सो फॉर एग्जाम्पल दिस वॉज द ट्री. अच्छा, यहाँ पे ये भी था, मैंने गायब कर दिया था. इसको बना देते हैं. इसकी क्या प्रॉब्लम, इसकी क्या कोई दिक्कत थोड़ी ना थी इस बेचारे में. ई नोड. ठीक है. सो व्हाट आई एम ट्राइंग टू से इज आई वांट द नोड जी फ्रॉम ए. सो ए डॉट राइट इज सी, सी डॉट राइट इज जी, ए डॉट राइट इज जी. अगर मेरे को एफ का वैल्यू प्रिंट करना है तो आई विल डू ए डॉट राइट डॉट लेफ्ट. Please make this diagram in your copy right now, and then you can have a feel of what I'm actually coding over here. ठीक है. मैं कोड जो कर रहा हूँ उस चीज का फील आना जरूरी है. अगर मैं a डॉट राइट डॉट लेफ्ट डॉट वैल्यू कर दूंगा तो चैट में बता दो प्रिंट क्या होगा. चैट में बता दो प्रिंट क्या होगा. तो प्रिया इज सेइंग 60 प्रिंट होगा. सही बात है क्या? देख लेते हैं. बात तो सही है यार, 60 ही प्रिंट हुआ है. I think you guys are now having an idea what I'm trying to say. So this was a very important thing what I was trying to tell you. This is a very, very important thing. ठीक है, because now you will be able to print the entire tree with only having the access of the root node. This is known as the root node, root, bap of the tree, father of the tree, right? Could you please show the diagram? Yes, I can show you the diagram. This is the diagram. ठीक है. It's very simple. मतलब you do not have to mug up this diagram. It is very simple. देखो 10, 20, 30, 40, 50, 60, 70. Every node has two children except the four nodes. A very, very simple diagram. 10, 20, 30, 40, 50, 60, 70. You can use any values. I have chosen these values. Okay. Yes. Ankunuru, Rishika is asking me, what if the tree is very lengthy? I'm going there eventually. Okay, I'm going there. Can we print the value of any node using its child node? No, we cannot. We cannot, because please see the arrow, right? Please see the arrow. Please see the arrow. From A, actually, we can go here. We can go here as well. Now from B, we can go here and here. And from C, we can go here and here. So eventually from A, we can go everywhere. But if we are at B, then We can only go to D and E. We can never visit A, C, F, and G if we are on B. So from a particular value, we can only just go down and we can never go up unless and until we make some kind of connections, but we are not doing it right now. ठीक है, वी आई एम गोइंग टू टेक 3 days a lecture. ठीक है, मतलब 3 days a lecture नहीं, आई एम गोइंग टू टेक दीज लेक्चर्स फॉर 3 days. ओके, यस, इट इज अ डायरेक्टेड ट्री. यू कैन ऑल्सो से दिस थिंग. वेरी नाइस. चलिए भाई, इधर आ जाते हैं. अरे कहाँ गया यार, फिर गायब हो गया. देखो फिर गायब हो गया. मैं क्या करूँ फिर अब? मैं इसको ले आता हूँ. ठीक है. आई होप यू अंडरस्टूड. नाउ what if something like this was the case that you cannot see the tree. You do not know about these child nodes. You do not know about these connections. You do not know anything except the root node. You have the access for with the root node. Can you print the entire tree? हम पूरा ट्री प्रिंट कर सकते हैं रूट नोड से? मैं कहता हूं yes we can. We can print. We can absolutely print using recursion. And in a binary tree, it is very much feasible because there are only, वैसे तो in any tree, but in binary tree, we have a left and a right. So please tell me, if I want to go from a node to its left and right, I can use recursion. Why recursion? So that when I am going to left, it solves its problem. Like I'm printing the node, then I'm saying recursion, bhai, please print the left part and please print the right part. That is your job. It is not my job. Okay. So what is the kind of code that we are looking? Let me tell you. For example, I want to print the entire tree. I want to print all the values of the tree. In any order, abhi ke liye, I am not concerned about the order. What I will do is, I will make a function known as print, and I will pass the node. I know, I hope you guys know about functions and methods. I hope. Now I will make, oh, not here यार, कहाँ गया? अरे अरे अरे, ये तो प्रॉब्लम हो गई. Yes, this is the note. ठीक है, I will make a function, public static or private static or whatever in Java in that you चिराग बहुत ही ज़्यादा वो हो रहा है, क्या बोलते हैं, अजीब. बैन कर देगा तुम्हें? अरे डिलीट कर दिया बेचारे को यार. बैन नहीं किया आपको, मैंने नहीं किया. अगर किसी ने किया है तो जीएफजी की टीम ने किया है. ठीक है. यस यार, वी विल प्रोवाइड द कोड्स. ठीक है, टेंशन मत लो, क्लास खत्म हो जाएगी, यूट्यूब पर सब मिल जाएगा. ठीक है. ठीक है. तो पब्लिक स्टैटिक वॉइड प्रिंट, आई विल मेक समथिंग लाइक दिस, वॉइड प्रिंट. ठीक है, वॉइड प्रिंट. ठीक है, वॉइड प्रिंट. इन दिस प्रिंट आई विल रिसीव अ रूट नोड. अब देखो, मैं इसका नाम कुछ भी दे सकता हूँ. आई कैन नेम इट ए, आई कैन नेम इट बी, आई कैन नेम इट जी, आई कैन नेम इट आयुष. ठीक है. बट द थिंग इज, root node is kind of a convention for this. Okay. So I have passed a, the root node, over this. And now this function has the responsibility to print all these 7 nodes. So what I do is I use recursion. I use the faith of recursion. So what happens in recursion? If you don't know recursion, you can also study right now, right here only. Recursion says that, okay, अभी मेरे पास क्या है? Right now, what are all the things I'm having? I'm having this root node. Can I print the value? Yes, I can. So print the value. ठीक है, print the value. I will print the value. Root dot value. Okay, I printed the value. Perfect. Now what happens in recursion is, I have to print the left node and the right node, and then the left and right of the left and right node. ठीक है, मैं एक बार डायग्राम दिखा देता हूँ फॉर ग्रेटर अंडरस्टैंडिंग. थोड़ा यहाँ देखो, इस चीज को प्लीज डू नॉट स्किप. ठीक है. कैन यू नॉट सी द कोडिंग स्क्रीन? लाइक राइट नाउ आई एम शोइंग दिस पर्टिकुलर स्क्रीन, बट इससे पहले आई वाज शोइंग द कोडिंग स्क्रीन. वी कैन सी. तो एक बच्चा गोली दे रहा है, कोई दिक्कत नहीं. इधर आइए, इधर आइए, इधर आइए, इधर आइए. सो व्हाट इज हैपनिंग इज, दिस वाज द रूट. I printed the value. Now I wanted to print 20, 30, 40, 50, 60, 70. कैसे करें ये सब? How can we do all these things? Using faith, using विश्वास, using भरोसा. So what we will do is, we know that if we have A, then A has some left, A has some right, and that left has some left and right, left and right. So we will not actually keep on printing keep on printing print a dot val, then print a dot left dot val, a dot right dot val, a dot left dot right dot val, a dot left dot val, a dot left right dot left dot val. दैट इज बुलशिट बिकॉज वी डोंट नो किसका कहां तक लेफ्ट राइट है. ठीक है, तो वी यूज रिकर्जन एंड वी से कि ठीक है भाई, इस बार फंक्शन में वी पास्ड ए, द नेक्स्ट टाइम वी विल मेक टू कॉल्स. व्हाई टू कॉल्स? बिकॉज this is connected to two people, so we will make two calls for every node. At max it is connected to two nodes. Acha, this can also happen that it is connected to one node, does not matter. Every node is connected to two nodes, please understand. If this is not a node, it will be a null. ठीक है, it is also a node, please consider. ठीक है, so every node is connected to two nodes, please understand. And null is the exit point. वेरी इंपॉर्टेंट, वेरी इंपॉर्टेंट, वेरी इंपॉर्टेंट. चलिए इधर आते हैं, अब कोड पे आते हैं. बहुत ही आसान कोड है. अभी मैं आपको बार बार जानबूझ के इंटेंशनली आई एम ट्राइंग टू टेल यू अगेन एंड अगेन ताकि इट फिट्स इनसाइड योर हेड. ठीक है सर, वाई वी यूज पब्लिक एंड स्टार्टेड? यार प्लीज, दिस इज नॉट द राइट टाइम टू आस्क अबाउट दिस. वेन एवर वी विल स्टडी मेथड्स इन जावा वी विल अंडरस्टैंड. अभी के लिए जस्ट प्लीज फॉरगेट अबाउट दिस थिंग, बिकॉज देन योर माइंड विल बी डाइवर्टेड इन the oops part, which it should not right now. Okay, so I said ki I am printing this, then I am calling left and right. How to call again? Print call the left, pass the left node. Oh, sorry, left node, and then I am calling the right node. That's it, this is the code. Itna sa bas 3 lines. Yes, now we have to make sure about one thing, because if I print this, if I call left, if I call right, then left will come here, left will print its value, left will call its left and its right. Now for example, what happens is, if I am at a level where the node which is passed is null. Yes, exactly, base case. Very nice, very nice. बहुत सारे बच्चे are saying base case. The base case is something like this. So if if the root is null, if the root is null, then I just told you that in null has no value, null has no left, null has no right, null has nothing. So we will return. What return does is, return means khatam, tata, bye bye, goodbye, gaya. Have you seen that meme of Rahul Gandhi? खत्म, टाटा, बाय बाय, गुड बाय, गया. सो रिटर्न मीन्स फिनिश फ्रॉम दिस पर्टिकुलर कॉल. फिर ये अपने आप पीछे चले जाता है जिसने इसको कॉल लगाया. अभी अभी वी विल सी द डायग्राम. प्लीज वेट फॉर 2 minutes मोर, प्लीज वेट फॉर 2 minutes. मैं ढंग से आपको ड्राई रन करके दिखाऊंगा, मजा आएगा उसमें. तो चलाए इस कोड, लेट्स रन दिस कोड. ठीक है, चलाए. यस, देख लो. कैन यू सी दिस थिंग? टेल मी इन द चैट्स. ऑल द नोड्स आर प्रिंटेड, ऑल द नोड्स आर प्रिंटेड. ठीक है, अब just to make you guys feel comfortable, I am doing two things. ठीक है, two things. The first thing is just to make you comfortable in the sense कि जो मैं कर रहा हूँ वो मैं सही कर रहा हूँ. ठीक है, जो मैं कर रहा हूँ वो मैं सही कर रहा हूँ. सो इधर आ जाते हैं थोड़ा. अब मान लेते हैं यार, ये तो थे हमारे पास. ठीक है, हमारा ट्री ऐसा था ना. इधर आ जाते हैं, वापस से ट्री बनाते. ओए कहाँ गए? ओए इधर. ठीक है, तो हमारा ट्री तो ऐसा था, हमारा ट्री ऐसा था. 10 था इधर बेटा, इधर 20 था, इधर वी हैड 30, वी हैड 40 ओवर हेयर इन लेफ्ट, वी हैव 50, वी हैड 60, वी हैड 70. वेरी बैड हैंड राइटिंग, एनीवेज. एंड इसको हमने ए बी सी डी, ये तो बस मैं नाम दे रहा हूँ, ए बी सी डी ई एफ जी. वी हैड दी 7 notes. Now what we will do is just to make sure कि my print code is actually in reality it is working. I don't know it is working or not. I don't know if the print node, the print function that I made is working or not. Maybe it is working only for these 7 nodes. What happens if, for example, I remove this node? So B has no right. B has no right node, right? And now F has two left nodes of value 80, मतलब one left and one right, and 90 named H and I. Let's make this code. Let's make these nodes, two nodes first, and let them get them connected to F left and right each. And let's remove B's right. And let us see that 10, 20, 30, 40, 60, 70, 80, 90 is printed or not without changing the code of the print function. ठीक है भाई, देखो इधर आओ, देखो जो हिंदी समझता है वो इधर आओ। इंग्लिश वालों को समझ आ गया जो मैंने बोला, ठीक है? अब हिंदी वाले ही समझो जो मैं कह रहा हूँ तुम्हें। ये देखो, इधर देखो, इधर। ठीक है, तो भाई ये आ गया हमारे पास। दिस वॉज द कोड, दिस वॉज द कोड। आई विल नॉट चेंज, मैं इसको नहीं बदलूंगा। इधर आते हैं। आई सेड दैट बीज लेफ्ट वॉज डी, आई एम रिमूविंग द कनेक्शन बी राइट ई। इट इज नॉट नेसेसरी टू रिमूव दिस नोड, इट इज लाइंग इन स्पेस। बट चलो एक बारी के लिए लेट्स कमेंट दिस कोड। ठीक है, दिस इज नो लॉन्गर अ लाइन। Now what I'm doing over here is I'm creating two more nodes. I'm creating two more nodes. I'm creating two more nodes. And we create nodes like this. The nodes were H. I can see them. You cannot see them. मेरी screen इधर है. I can see them. Node H with the value, new node into value. Its value was 80, 80. And I was creating one more node, I. And the value of I was 90. It was 90. And I actually connected them as well. Actually connected them as well. I was connecting them at F. So F dot left is for example H. F dot right is for example I. Okay. देखो please समझो. I created these two nodes and I did these connections. I removed this left wala connection. In fact, I should actually write this B's right is equal to E. I am actually commenting this. Okay, so I removed this and this. Okay, I created these things. Let me run the code again. Again, the print function is being run. Okay, the print function is being, let's check. As you can see, 10, 20, 30, or 20, 20, 40, 30. Now you might be thinking why 31st and why 41st and 30 after that. We will talk about that in a moment. Even before this, it was not the exact order of 10, 20, 30. I don't think anyone noticed that before. Did you guys notice? I'm talking about this. For example, these are commented and let's talk about the old tree. This is our old tree, Purana wala tree, and then run it. So as you can see, it is 10, 20, 40, 50, 30, 60, 70. It is not 10, 20, 30, 40 like this. That is level order traversal. We will study in 5-10 minutes. But all the nodes are printed. That was the scene. Okay. Now let's थोड़ा इधर आ जाते हैं and do it again. So you can see 10, 20, 40, 30, 60, 80, 90, 70 are there. Only 50 is missing. Was 50 missing in my diagram? It was. It was. Let me confirm it. Let me 10, 20, 40, 30, 60, 80, 90, 70. It was as you can see 10, 20, 30, 40. There is no 50. So these new nodes are being printed. So no matter now, whatever I do, I make these two child nodes, then these two child nodes and child nodes and child nodes and a very, very big tree. Every node will be printed if I use recursion. Why? Why? Now, before doing the dry run of the recursive part, I want you guys to understand what recursion is. If you understand understand recursion and you understand the trust, okay, trust recursion, I would say, trust the process, trust recursion. If you start trusting recursion, now you can solve any question. Because what recursion did is it printed nodes value. Then it said ki, okay, call the left, it will print all these nodes. Call the right, it will print all these nodes. I have to do nothing about it. I have to mention a base case only, wherein when null comes, I will say that, okay, it is nothing, just go back, return. Okay, so you have to trust recursion. Okay. Also a very, very important factor, let me tell you. In a tree, there are three parts in a tree. Three parts in every tree. Please remember, in every binary tree we have three parts. You might be thinking, okay, there are 1 2 3 4 5 6 इतने सारे nodes हैं यहाँ पे, तो there are a lot of nodes. How can these be divided in three parts? Every single tree can be divided in three parts like this. So this is the left subtree. ठीक है, कलर भी हो गया देखो. This is the right subtree. This is the right subtree. Please, guys, understand this thing. And this is the node. So we have root, left subtree, right subtree, left, right, SUB, subtree का concept समझो. Subtree. Okay. So can you not say that this in itself is a binary tree? Yes, it is. It is. Can you not say that, like even in a generic tree, if I pick up this node and forget about this thing in itself is a tree. Now again, if I move to this tree, if I just forget about this part, this in itself is a tree, node and child nodes. So every subtree of a tree is a tree, right? What I'm trying to say is this in itself is a tree, this is a tree, this is a node. So any tree is represented like root, left subtree and right subtree. Please write this thing in your notebooks or whatever, because this is an extremely important concept. Using this concept, we will solve all questions. Okay, you have to understand this and you have to trust recursion. So what recursion was doing is, because whenever we called the function print, initially we passed the root, for example, this root. So we actually did not just pass the root, we passed the entire tree. Whenever we pass this, we pass the entire tree associated with this. Whenever we pass this node, we pass the entire tree associated with this node, right? Because we can access it. Of course, if we are passing this node, we can never access these values. But if we are passing this node, we can access all values. Okay? So what we are doing is, what recursion is doing is, let's come to the code again and let me make you trust recursion. भरोसा दिला रहा हूं मैं आपको recursion के ऊपर, that we know the structure of a tree. It has a root, it has a left subtree, it has a right subtree. The value of root is printed. Then I am calling the function again. I am saying recursion. कर ले यार तू, तेरा काम है. Recursion is printing all the values. Recursion is printing all the values in the right subtree. I'm just making a base case. ठीक है? Please tell me in the chat if it is. सर बाकी कॉन्सेप्ट भी करवा दोगे? आज नहीं हो पाएगा कुमुद, अगली 2 क्लासेस में. ठीक है? Sir, what is the time complexity? I will tell you about the time complexity when we reach DFS and BFS. It is big O of n, the number of nodes, if n are the number of nodes. Sir, can you please draw recursion tree once? Yes, Vignesh, please wait. You were not defined root, so how to call root? I did not get you, Priya. Actually, we did define. Oh, okay, I got you. If you students are thinking that here it is mentioned as root, right? And in this main function, there is no root. I am actually calling A. So why the hell this is not A? I think ये आपका डाउट होगा, but I think you should know basic concepts of coding. Even if we pass a particular array or if we pass a variable, we can change the name of the variable and it will still hold the same value, right? In case of arrays, and technically what this node is an object. It is a data type, kind of a data type, but it is an object. So whenever we pass objects into functions, we can change their name. This root, the name will be root, but technically it is pointing to A only. This is A. इसका बस नाम मैंने बदल दिया है, right? This is A. Okay. Yes, I have scrolled. Are you seeing this node? ये तो बड़ा बेसिक है, इसको you can write. ठीक है. Sir, how the roots are shifting to their child nodes for further printing? ठीक है. Now let me do the thing, so you can understand. हाँ शुभम यार, आप वहीं चले जाइए. ठीक है. You are only concerned about a particular person changing his job or not, and not about your placements. विच इज़ वेरी बैड, बट एनीवेज अब आ जाते हैं हम फटाफट यार यहाँ पे। कहाँ पे? यहाँ पे। कहाँ पे भाई? अरे यहाँ पे। अरे कहाँ पे? अरे यहाँ पे। आ ही नहीं रहा, देखो आ गया। ठीक है, चलो अब दिख रहा है। अब दिख रहा है। ठीक है, अब दिख रहा है। ठीक है, अब आ जाइए इधर। लेट मी जस्ट ड्राई रन द कोड। नाउ आई एम मेकिंग माई ओरिजिनल ट्री फॉर यू गाइज टू अंडरस्टैंड बेटर। ठीक है, आई एम मेकिंग अ ट्री ऑफ लेस नंबर ऑफ नोड्स, लाइक दिस इज नॉट लेस exactly. These are 7 nodes which are being printed. ठीक है, these were 7 nodes. I'm making my original tree. The names were मतलब मैंने in the main function I named them A B C D E F G and I put the values as 10 20 30 40 50 60 70. अच्छा, remember this thing when I was trying to print this tree or all the values of this these all the values of the nodes of the tree. So in the output screen, okay, in the output screen, so by output screen, I mean that whenever I am showing you IntelliJ IDEA wali screen, so here I am writing the code and here the output is coming. Okay. So in the output screen, you guys must have noticed that the order of the values was very weird. Actually, I know what the order was. Let me do something. Okay. I for sure that it was 10 and it was then 20, right? It was 40 and 50. Then it was 30, 60 and 70. I'm pretty sure in this particular order, the values were printed in this particular order. I can even show you. Please please write it down in your copies. Let's do a exercise 10, 20, 40, 50, 30, 60, 70. Right? Now I will print it and I will tell you guys how in the world did I predict कि यही वाली values थी, and even if I change the tree I can always predict it. ठीक है, not predict, I can actually solve it. So let me go to the screen again and let's move to the original tree. So our original tree was something like this. This was the original tree, and let's remove these things. So this was the tree with 7 nodes, 10, 20, 30, 40, 50, and the connections are also perfect. Let me run the print code. And you can see 10, 20, 40, 50, 30, 60, 70. और मैंने यही लिखा था, है ना? चलो अब मैं आपको बताता हूँ ये क्यों हुआ है। प्री ऑर्डर ट्रेवर्सल है, इन ऑर्डर नहीं है। मैं आपको बताता हूँ, वो सब चीज़ें बाद में आएगी यार, अच्छे से आएगी ट्री ट्रेवर्सल। अभी मैं वही पढ़ाऊंगा, बट थोड़ा सा पेशेंस, थोड़ा सा पेशेंस। ठीक है, लिटिल बिट ऑफ पेशेंस is a very nice thing for you guys. ठीक है, now let me go to my iPad screen and let me show you the magic, how the magic is happening. ठीक है, let me write the code as well. Actually the code was this. It was void print and that then a node was received. ठीक है, and then I was doing the base case if root is null, I am doing return. okay, इसको थोड़ा ऐसे लिख देते हैं. Then I was doing something like this. I was printing system.out.print.ln or cout in C++ or print in Python. I was printing the value and then I was calling its left, sorry, print function. I was calling its left. Then I was calling its right child. Please see this thing very carefully. मैं दो बार ये बात नहीं बताऊंगा. Just kidding. I will tell you 5-6 times also if you do not understand. ठीक है, दिस वॉज द कोड. मैं इसको थोड़ा ऐसा लिख रहा हूँ ताकि आपको समझ आए. ठीक है, दिस वॉज द कोड, राइट? दिस वॉज द प्रिंट फंक्शन. सो आई पास्ड रूट. व्हाट हैपेंड इज technically initially I said that okay, root was this. I am making a variable r. Please understand that r means root in this case, just to make it short. Okay, so initially r means this node, a also means this node. Got it? ठीक है. So let's move on to the code. What is happening? If root is equal to null, return. So is this root null? Please tell me in the chat. Is R equal to null? Is R equal to null? It is not null. So if it is not null, then return will not happen. So ignore this line. भाड़ में गई ये line. Side करो इसको. अब इधर आए. South root dot value. इसको side करते हैं पहले. ठीक है. We will predict the answer. So I printed root value. Root value is 10. Print 10. Also give a next line because it was ln. It can be ignored as well. Anyways. Now what I did is I printed root dot left. So I am in this line. This in itself, it calls a function. It calls a function. And what it does is roots left was B. So now this B node is passed in this function. Now root is B. So please understand, अभी के लिए ये इधर आ गया है. ठीक है. Now root R is referencing this particular node. Okay. Please understand. Currently, I am not in the right part. I'm not in the right part. Actually, इसको समझने का एक आसान तरीका है. There is a easier way to understand all of these things, which is I am printing A, then I am printing left subtree, then I am printing this. Okay. So I'll tell you what the output is. I will write the output over here. What I'm doing is I am printing A, then I am printing this particular tree 20, 40, 50. I'm writing this in a bunch, like आप कैसे भी लिख लो इसको. For example 40, 20, 50. I am printing this 10. I am printing this and I am printing 60, 30, 70 or whatever. ठीक है. I am printing this and this. Now this is a node in itself. तो ये तो ऐसे ही प्रिंट हो जाता है. ठीक है. This in itself is a tree. This is a tree. Please इसको भूल जाओ. Forget about this. Only focus on this small tree. In this small tree, what is happening is I am printing first of all the value of the root. 20 will be printed first. Then I am calling left, so 40 will be printed. Then I am calling right, so 50 will be printed. That is why it was 20, 40, 50. Similarly, here it was 30, 60 and 70. Got it? What is happening in recursion? वो आपको बताता हूं थोड़ा सा with this orange line. Please look at this line. So initially we are at A. We are at A. ठीक है, we are at A. Then we are at B. We are at B. ठीक है. Because it is not like कि, please understand, what happens is if one function is calling another function, ठीक है, and if one function is calling more than one functions, like this print function is calling itself but twice or maybe thrice, more than once. So it is not like कि this function has called these two functions simultaneously. या हिंदी में बोलूं तो ऐसा नहीं होता कि एक फंक्शन ने दो फंक्शन को एक साथ कॉल मिलाया है. नो 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 नो. द सिचुएशन इज समथिंग लाइक दिस. फॉर एग्जांपल आई कैन वन नेम इज प्रियंका, another name is Nitin. ठीक है. So I'll take some names. For example, I am the root node. My name is Raghav. ठीक है. I'm Raghav. I am the root node. I have a value 10. So I'm sitting at my home and I'm actually calling people. So what is actually happening is I have to call, Raghav has to call Priyanka and he has to call Nitin. ठीक है. So he is not calling them एक साथ or together. Firstly, Raghav is calling Priyanka. ठीक है. Now Priyanka calls its left and right order wise. Priyanka calls, for example, Keshav. Then the call of Priyanka and Keshav, I'll write this thing. I will write this thing. I will write this thing. A B C D E F हटा देता हूँ बेटा आपके लिए. एक सेकेंड. मैंने फोन क्यों रख रखा है तब से कान पे. ये देखिए देखिए, रुको रुको रुको. राघव, प्रियंका, ठीक है, केशव. प्लीज अंडरस्टैंड. आई विल टेल यू द एंटायर कॉन्सेप्ट. प्लीज लुक एट दिस प्लीज. ठीक है. नितिन, प्रथमेश का तो नाम बड़ा है, कुमुद, सॉरी प्रथमेश, एंड आदित्य. एंड एक और चाहिए मेरे को. आई नीड वन नेम. आई नीड वन नेम. सिद्धार्थ इज द बिग नेम. आई नीड अ स्मॉल नेम. आई नीड सैम. ठीक है. सॉरी सॉरी गाइस. सबका नाम नहीं ले सकता, ठीक है। सो देर आर 7 पीपल इन टोटल, देर आर 7 पीपल इन टोटल, ठीक है। सो व्हाट इज हैपनिंग, प्लीज अब इधर देखो, अब इधर देखो, everyone please have a look at this. Raghav, actually the work of Raghav is to call these two people. Priyanka has to call these two people. Keshav has to call these two people, ठीक है। How it happens is not like कि I have actually conference called Priyanka and Keshav and they have conference called these four. No, no, no. This is not recursion. Recursion is first left, then its entire work has to be finished, then only it moves on to the right call. What is happening, the calling order, I'll tell you. Raghav calls Priyanka first, okay, tells her some information. Priyanka calls Nitin, tells her some information, and then the call is cut, okay. Please understand, I'm making some lines, so Raghav called Priyanka, Priyanka called Nitin. Now the call is over. Now the call is over. Nitin called back Priyanka. Like this arrow means it is over. Okay. He has received the information. Now Priyanka will call Kumud. She tells all the information to Kumud. Kumud says, okay, thank you very much. Tata, bye bye. Now Priyanka says, okay, my work is done. Raghav already told me my information. So my work is done. Now Raghav calls Keshav. Now Raghav calls Keshav. Now Keshav first because the order is left and right. Please understand. ऐसा नहीं है कि पहले right पर. No, no, no. Keshav calls Sam, gives an information. Sam says, okay, thank you. Then Keshav calls Aditya. Aditya says, okay, thank you. Wait. अभी खत्म नहीं हुआ. It is not over. Then Keshav says, okay, my work is done. Okay, Raghav, thank you. This is recursion. This is recursion. Please tell me in the chats अगर मजा आ गया तो. If it was very nice. And all the people who are only understanding English, please tell me in the chat that it was understandable even in English. Okay. Got it? Yeah. मजा आ गया ना? In English and Hindi both. Right. Sir, we cannot do DSA without OOPS. Yes, you cannot do, Arpita, unfortunately, DSA without basic theoretical OOPS. Sorry, practical OOPS. Sorry. The node class and everything, you have to understand that. Okay. But now you can never understand linked list and trees. So, आगे के topic भी you cannot. Yes, Sahil, actually, it will be added in the description of the YouTube video that जिसमें ये live चल रहा है ना, तो tension लेने की जरूरत नहीं है. ठीक है, display the code please. This is the code, बेटा. This is the code. This is the code. ठीक है, इसी को मैंने यहाँ लिख दिया. अभी दिखाऊंगा, कोडिंग स्क्रीन पे भी आ जाऊंगा. बट आई थिंक आपको समझ आ गया होगा कि हाउ कॉलिंग वर्क्स. नाउ एक बार हम इधर आ जाते हैं. टाइम कॉम्प्लेक्सिटी इज एक्चुअली बिकॉज व्हाट वी आर डूइंग इज, प्लीज अंडरस्टैंड, अब टाइम कॉम्प्लेक्सिटी समझने के लिए भी, टाइम कॉम्प्लेक्सिटी. So if we have a total of n number of nodes, in this case n is equal to 7. So the time complexity is actually of visiting and printing is big O of n. Why? Because what is happening is technically Raghav is calling this and this, right? And he is getting a call back from Priyanka and Keshav. Right? Getting it? Like Raghav called Priyanka first, give her the information, not cut the call, put the call on hold. Then she reverted back that it is done. So technically what is happening is each node is printing itself, then it is calling left and right, and when it is calling left and right, it is coming back as well. Okay. So the total, if I say the number of interactions and number of the arrows, as you can see, is actually double the number of nodes. So 2n interactions. So the time complexity is big O of n only. 2n and n and 3n are same. Okay, they are similar. Yes, the space complexity is also big O of n, not big O of n. I'll tell you about the space complexity. It is big O of h actually, height of the tree. But uske liye please wait. for the next class or maybe this class, but after some time. Okay. I will be sharing the code. Please do. First of all, देखो, I will be sharing the code, but I actually want you guys to code it yourself, right? The session will be available for you even after this class is over. So the better thing to do is not to copy my code. It is to write your code. Yes, if you are coding in some other language, then you can copy the code. ठीक है? And we will be providing you the codes in the description of the YouTube video. Okay. हाँ. So print K using star. Kumit, yaar, this is not a pattern printing class. In a pattern printing class, I will be taking that doubt, or maybe in any other doubt class. Okay. So let's move to the next topic. I think this is understood. And now let's do one thing. Let us do one thing. This was a tree. This was a tree. Acha, I will be also sharing these annotated notes. I hope these notes will be very, very helpful for you students, right? So I will be sharing these notes. Acha, let me make one more tree. 10, 20, 30, then 40, then 50, then 60, then 70. So this is also a tree, very interesting diagram. So what is happening is 10 has left and right, 20 only has left, the right is null, 30 has only right, the left is null, 40 left is null, 50 it is also null. So this is kind of the tree. So this interesting shape. Now, if I want to actually print all the elements of this tree, and I am using this particular code, will the nodes be printed? Please tell me in the chats. Will the nodes be printed? And if they will be printed, tell me the output as well. Let us see आपको समझ आया या नहीं आया. I want to check if all these nodes will be printed. Yes. What will be the output? Is the output something like this? Of course not. Then what will be the output? ठीक है. Sumansi is writing, Priyanshu is writing, Arya is writing, नेहा is writing, मंगेश is writing, समीर is writing. एक बार देख लेते हैं. एक दूसरे का टेप रहे हो ना? सही बताओ. सही सही बताओ. नहीं. चलो अच्छी बात है. अच्छे बच्चे हो. 10, 20, 40. ठीक है ठीक है. चलो इधर आ जाते हैं, इधर आ जाते हैं, इधर आ जाते हैं, इधर आ जाते हैं, इधर आ जाते हैं. अच्छा, बाय द वे, एक छोटा सा प्लगइन. ठीक है. आ, ये मत समझना कि मैं अपना कोर्स बेच रहा हूँ. बट द थिंग इज टेक्निकली यस आई एम. सो मेरा एक कोर्स है. ठीक है. तो जीएफजी में आई एम गोइंग टू टीच, यही जीएफजी में डीएसए लाइव with like this is a live session. So I'll be taking a live session, and again the number of users won't be that much because it is a paid course. So I am going to take a GFG DSA live. The announcement will be there on YouTube soon, very soon. Abhi to there is no announcement of this thing, and I think from 1 June or something like that, the batch will be there. जहाँ पे complete DSA from scratch I will be teaching. So all the basic topics as well, like arrays, ultimate questions of arrays, recursion, and everything. Like this conceptual, what I'm trying to teach over here is, ठीक है. The mode will be English, and I'll be teaching that. तो अगर आपको वो चाहिए होगा तो यू कैन चेक आउट. अभी तो बहुत बाद में आएगा. ठीक है. इनफैक्ट प्लीज राइट इन द चैट हाउ मेनी स्टूडेंट्स आर एक्चुअली excited for the batch. मतलब interested for the batch, not excited. If you are interested in the batch. ठीक है. आनंद इज सेइंग नो. सॉरी आनंद, बुरा हूँ क्या मैं इतना? ठीक है. नहीं नहीं, प्राइस तो बहुत अफोर्डेबल होगी. इट विल बी वेरी अफोर्डेबल. ठीक है. या नॉर्मल जैसे लाइव बैचेस होते हैं यूट्यूब पे आपको दिखते होंगे, जो भी क्रिएटर्स भी बनाते हैं. सो वैसा है. ठीक है. आप लोगों के लिए डिस्काउंट दे देंगे, ऑल्दो मेरे पास कोई कूपन कोड नहीं है. बट एनीवेज, ठीक है. नॉर्मल अफोर्डेबल बैच ही होगा. लैंग्वेज यार वैसे सीपीपी, सी प्लस प्लस या जावा में से कोई होगा, लेकिन आई विल मेक श्योर कि लैंग्वेज सारी होगी. ठीक है. मतलब आपको सबके नो कोड्स पहले से ही मिल जाएंगे. क्लास स्टार्ट होने से भी पहले इनफैक्ट, एंड आपको टीए सपोर्ट भी अकॉर्डिंगली सारे लैंग्वेज में मिल जाएगा, तो कोई दिक्कत नहीं होगी। ठीक है, ड्यूरेशन 3 महीने समथिंग, 3 मंथ्स। यूट्यूब पे भी आएगा, देयर विल बी अ फ्री कोर्स एज वेल ऑन यूट्यूब, बट द थिंग इज ऑन यूट्यूब द कोर्स विल बी रिकॉर्डेड, राइट? सो इन द लाइव कोर्स द ओनली थिंग दैट विल बी बेटर, द कंटेंट इज सिमिलर ओनली, ऐसा नहीं है। द ओनली थिंग इज दैट यू विल बी, आई विल बी एक्चुअली क्लियरिंग योर डाउट्स इन द लाइव क्लास, सो दैट इज अ benefit of life. Otherwise the content you can get it for free also. It totally depends on you. ठीक है, if you cannot afford it then yes, YouTube is a better option. ठीक है, आई डोंट नो हाउ मेनी किड्स विल बी देयर, वो तो डिपेंड करता है कि हाउ मेनी किड्स विल कम इन द बैच। एनीवेज यार, इधर आते हैं ना यार, मुद्दे से क्यों हम भटक गए, आउटपुट पे आते हैं। लेट अस प्रिडिक्ट द आउटपुट। ठीक है, लेट अस प्रिडिक्ट द आउटपुट वाया द कॉलिंग मेथड, वाया द कॉलिंग मेथड। ठीक है, ठीक है। आई वोंट बी राइटिंग नेम्स नाउ बिकॉज द लेक्चर विल बी लेंदी, सो प्लीज अंडरस्टैंड. What happens is, of course, initially I am at 10. Initially I am at 10. I am taking two colors. So 10 calls 20 and 10 calls 30. But I already said that 10 only calls 20 first, then 30 after completing all the work. So I am making a dotted line. Please understand. 10 calls 20 and 10 calls 30. 10 has yet not called 20 30. It has not called 30. It will. ठीक है, it first of all, before calling 20, 10 gets printed. ठीक है, then 10 calls 20, then 20 will call 40 and right child, right? So 20 calls 40 and 20 calls its right child as well, but not now. It will eventually, it will. Okay, after the callback, please understand. Now 20 also gets printed first. Really sorry for that. I missed it. 10 आया, 10 प्रिंट हुआ, 10 ने लेफ्ट कॉल लगाई, 20 आया, 20 प्रिंट हुआ, लेफ्ट कॉल लगाई. इट हैपन समथिंग लाइक दिस, लेफ्ट 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 लेफ्ट, देन राइट लेफ्ट राइट लेफ्ट राइट लेफ्ट. आई टेल यू. So 40 gets printed first. Again 40 does what? 40 does something like this, that it calls its left first. Please understand. It is not calling 60. It will. It calls left. Now what happens is the left was actually null. Okay, there is nothing, right? Now whatever, whenever we get a null, what we do is we return. So what return is nothing. Return is like khatam, tata, bye bye, goodbye, gaya. It redirects it. So return was this color arrow. Okay, so return. Every function is returning, but the null is returning immediately without printing its value and calling left and right. So we come at 40. Now 40's left work is done. Now 40 will actually call what? 60. It called 60. 60 printed itself. 60 also calls its left and right. Please remember, 60 also calls its left and right. But because the left was null, so a callback happened. Okay? Like it returned, and then it called its right, which was again null. So it returned. Now 60's work is done. 60 has printed itself. 60 has called its left and right child. 60's work is done. Because 60's work is done, it will do return. Okay. Now we are at 40. We are at 40. 40's work was already done. 40 was printed. We had called left and back and right and back, right? So 40's work is done. Now 40 will go here. 20. Now 20 will eventually call its right child. Yeah, it was null. So null तो तुरंत ही ये कर देता है immediately. Now 20 is printed, 20 is left, entire is printed, 20 is right is also done, 20 also called back. ठीक है? Yes, it is backtracking actually. I was missing the word. Right? Technically speaking, it is backtracking. ठीक है, it is backtracking. But not exactly backtracking, मतलब but still. Anyways, हम 10 पे आ गए. So what 10 did is 10 called 30 now. Because 10 was printed, yes. 10's left work is done. Yes, ये देखो, ये हुआ, ये भी हो गया. Now right is done. So 30, first of all, prints itself. 30 calls left and 30 calls right. 30 calls left, it is null. So वापस आ गया. 30 calls eventually finally right. 50 gets printed. 50 calls it's left. 70 gets printed. 70 calls it's left. Okay, it is null. Call back. 70 calls it's right. Okay, it is null. Call back. फिर 70 has its work being done. It calls 50 again. मतलब it backtracks to 50. Now 50 will call its right child, which is null. It will be back. It will be back. It will be back. And then eventually ये वाला भी चीज होती है एक्चुअली में. क्या? रिटर्न. द रूट रिटर्न, मतलब द फंक्शन इज ओवर. ठीक है. तो प्लीज टेल मी इन द चैट इफ इट वाज अंडरस्टैंडेबल. एंड अब यू विल नेवर हैव अ प्रॉब्लम in printing tree. Okay. Yes, it is an activation tree of recursion, right? And now let me also make a recursive tree as well for you guys, for you to better understand ki what actually happens. This is also necessary. इसको हम यूलर ट्री कहते हैं. आइलर और यूलर्स टोर ट्री. ठीक है. द मैथमेटिशियन यूलर आई थिंक. सो लेट मी मेक सम ट्रीज फटाफट. 10, 20, 30, 40, the standard, the old one. So what actually happens is this is the tree. This is the tree. This is the shape. अब आपको थोड़ा थोड़ा समझ आ रहा होगा कि हो क्या रहा है. ये रूट्स जैसा लग रहा है. दिस इज लाइक रूट्स, लाइक दिस इज लाइक रूट्स, है ना. सो what happens is we are at 10, then 20, 40, then again 20, then 50, then again 10, then 30, 60, then again 30, then 70, then again 30, then 10. ऐसे चलता है पूरा मामला. दिस इज प्री ऑर्डर, इन ऑर्डर, पोस्ट ऑर्डर, जो कि अभी आई एम टेलिंग ऑफ यू, जो कि आई विल बी टेलिंग यू. ठीक है. तो दिस इज द थिंग. ठीक है. नाउ अगेन यहाँ पे भी कैन यू मेक द यूलर ट्री? यस आई कैन मेक. तो फ्रॉम 10, 10, 10, 10, देन इधर से वापस आ रहा है, बट वी कैन इग्नोर नल. सो एक्चुअली व्हाट इज हैपनिंग इज समथिंग लाइक दिस ओनली. ठीक है. इन दिस द यूलर टोर ट्री वाज लाइक दिस. ठीक है. यस, दिस इज DFS, डेप्थ फर्स्ट सर्च. कि डेप्थ वाइज वी आर गोइंग. दिस इज अ DFS कि वी आर कॉलिंग 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 बैक 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 बैक, कॉलिंग 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 बैक 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 बैक. एंड ऐसे ही मेरा काम हो रहा है. राइट. दिस इज हाउ द थिंग्स आर वर्किंग. नाउ लेट मी डू सम इंटरेस्टिंग थिंग्स. वी विल गो बैक टू द ओल्ड ट्री and I will teach you pre-order, in-order, post-order. Like you have been never taught in your life. ठीक है. ऐसा कम ही पढ़ा होगा आपने प्री, इन ऑर्डर, पोस्ट ऑर्डर, जो कि अभी मैं आपको बताने वाला हूँ. मजा आ जाएगा. ठीक है. चलिए आते हैं इधर. एंड फिर उसके बाद हमारी क्लास फिनिश हो जाएगी. ठीक है. इधर आते हैं. कुछ सवाल भी करेंगे. सवाल तो किए ही नहीं है यार. Naisha, you will be able to see today's class recording on YouTube on Geeks for Geeks YouTube channel. You have to write Geeks for Geeks. In the live section, I think in the live section, it is currently happening also. It is happening also. Let me check in YouTube. So Geeks for Geeks. और उन बच्चों को लाइफ का जवाब नहीं दे पा रहा हूँ मैं. हाँ, इट इज हैपनिंग. हाय राम. ओहो. यूट्यूब पे. यस. हाँ, इट इज हैपनिंग. ठीक है. ठीक है. ठीक है. ठीक है. ठीक है. ओके. ठीक है. एनीवेज, इट विल बी अवेलेबल ऑन यूट्यूब लाइव सेक्शन. ठीक है. थोड़ा नीचे जाके यू हैव टू स्क्रॉल. चलिए चलिए. एक बच्चे, अच्छे बच्चे धीरज ने लाइव सेक्शन का लिंक भी दे दिया है. यू गाइस कैन सी इन द चैट देयर इज अ लिंक ऑफ यूट्यूब लाइव एज वेल. सो यू कैन फाइंड द लेक्चर एट दिस लिंक एट एनी टाइम. ठीक है. ओके. डीएफएस एक्सप्लेन तो कर ही दिया. इधर आते हैं, इधर आते हैं. ठीक है. अब फियर ट्रीज का चले जाएगा आपको पूरा. अब प्लीज लुक एट द स्क्रीन, लुक एट द स्क्रीन. दिस इज आवर ओल्ड ट्री. दिस इज आवर ओल्ड एंड ट्रस्टवर्दी ट्री which has 10 to 70 values in some random order. Not random, not random. This order is known as pre-order. Why pre-order? लेट मी टेल यू, एक सेकंड रुक जाइए बस. What will happen, please tell me students, what happens if I do something like this कि I remove this line, I call right first and left after that. Please tell me in the chat, will all the values from 10 to 70 be printed or not? बस इतनी सी बात बता दो कि ये सारी वैल्यू प्रिंट होगी या नहीं होगी. बस इतना सा चेंज किया है मैंने, पहले राइट फिर लेफ्ट. Students are saying yes. Let me check. Yes. But you can see the order is different. The order is different. 10, 30, 70, 60, 20, 50, 40. The order is different. In fact, let me do it again. This was the original thing. Now please remember, इसको आप remember कैसे करोगे, मतलब memorize कैसे करोगे? It is something like this. It is something like this. It is like this कि I'm printing the value root left right, या फिर node left right. Printing the node's value, going to left, going to right. Node left right. Node left right. Please remember this thing. What if, now tell me, now please tell me, now please tell me, now please tell me, if I cut this line and I make the print statement between both of the calls, now tell me all the values from 10 to 70 will be printed or not? Will they be printed or not? Students are saying yes, printed. Let me just run the code. Yes, all the values are there, but the order is different. Now 40 is printed first, 10 is printed in middle, and then 60, 30, 70 is there. And if what I do is I print after both of the calls, again all values are printed, but 10 इस बार लास्ट में है. ओ प्यारे बच्चों, 10 लास्ट में है कि यू कैन सी 10 इज इन द लास्ट दिस टाइम. ठीक है, एवरीथिंग इज रिकर्जन. यस, दिस इज ऑल्सो रिकर्जन. द ओनली थिंग इज कि इफ आई मूव द प्रिंट स्टेटमेंट, ठीक है, इसको ना हिंदी में मैं ऐसे समझाता हूं. दोनों कॉल से पहले का काम, दोनों कॉल के बीच काम, दोनों कॉल के बाद काम. ठीक है, सो वर्क बिफोर बोथ ऑफ द कॉल्स, दिस इज अ थिंग. ठीक है, वर्क बिफोर बोथ ऑफ द कॉल्स कहां गया? शिट, द प्रिंट स्टेटमेंट इज गॉन. एनीवेज आई विल राइट इट. सो वर्क बिफोर कॉल्स, वर्क बिटवीन द कॉल्स, वर्क आफ्टर द कॉल्स. ठीक है, दैट इज द कॉन्सेप्ट. And actually, all these three things, left and right being in the odd same order, left, right. I will tell you about right, left also after some time. But in left, right, if I print before, in between, and after, then these become the three orders of DFS, which is pre-order. Like pre means what? Pre means previously, like before. So pre means before both the calls I'm doing the work. Now there is something known as in order, in order, like work between the calls, in between the calls, in between the calls, and work post the calls, after the calls. Post order, after मतलब बाद में. ठीक है, it is very easy. So this is pre in order, post order, and in order in action. Right, now this is the code for pre-order. Again, इसको दोनों के बीच में रख दो, in order and post order. Let me go to the iPad screen and show you incredible things. इधर आते. Difference between BFS and DFS. So Arshad, all these three things which I showed you, pre, in, post, are all DFS. D for donkey. BFS हम बाद में पढ़ेंगे in the next class. It is completely different. ठीक है, so let's move on to this particular concept of pre, in, like पूरा लिख देता हूं. So pre-order, in-order, post-order. ठीक है, and first of all let's talk about pre-order and how pre-order is working. Then we will talk about in-order and post-order, and we will यूज दिस ट्रस्टेड ट्री। थोड़ा अच्छा डायग्राम बना सकता हूँ ना मैं, ये तो गलत बात है। एक तो कलर क्यों फिल हो रहा है, चलो कर देते हैं। अरे वाह, ये क्यों हो रहा है? एक सेकंड दे दो बच्चों, मेरे को प्यारे बच्चों, एक सेकंड बस। अरे अरे, ऐसा क्यों हो रहा है मेरे साथ? ऐसा मेरे साथ क्यों हो रहा है? ठीक है, थोड़े नोट्स की वैल्यू शेप अलग है बट समझ जाना। ठीक है, गिव मी 1 सेकेंड प्लीज, दिस विल बी वेरी हेल्पफुल फॉर फ्यूचर पर्पस। ठीक है। हम्म, सॉरी फॉर द डिले, सॉरी फॉर द डिले। ठीक है, सो आर यू एबल टू सी दिस डायग्राम? प्लीज टेल मी, आर यू एबल टू सी दिस ट्री? यस, ओके। Let me copy this because this will be used 2 times again in order and in post order. ठीक है, इधर आ जाते हैं। Right. What happens in pre-order is there are multiple ways of understanding and predicting the output of pre-order. So the output will be something like this. For the output, what you actually do is, what pre-order is node या root left right. This is the concept. Node left, right. Please understand this. The concept is node left, right. Before the left, right calls, I'm printing it. So, for example, I'm standing over here. I'm standing over here. What node means is printing the node. So I have 10, this left subtree and the right subtree. So output will be 10, 20, 40, 50, and 30, 60, 70. Please remember, what I'm doing is abhi I do not know, I'm making a bracket here because I do not know if 20, 40, 50 or 30, 60, 70 what will be printed first. Please understand. But I definitely know that first it is the node, then it is the left subtree that will be printed, then it is the right subtree that will be printed. Okay, understanding? First it is the node that is printed. Okay. Then the left subtree will be printed. I don't know it in which order. I will figure it out. Then the right subtree will be printed. I don't know in which order. I will figure it out. ठीक है, अब आ जाते हैं हम इधर। Please come in the left subtree. This in itself is a tree. This in itself is a tree. So because this is a tree and we are applying recursion, basically we are applying the same thing in this node what we were applying on this node first. Now this is the root. This is the left, this is the right. This is the node, this is left, this is right. Initially this was node, this complete was left, this complete was right. Now in this particular part, this is node, this is left, this is right. So we want to print in which order? Node left, right. So node 20, 40, 50. So as it is, वो तो हमने लिख दिया ऐसे। तो 20, 40, 50, node left, right. And then इधर भी we will do node left, right. So 30, 60, 70. Please understand, अभी you will understand this more when I teach you in order and post order, तब आपको ज़्यादा मज़ा आएगा। अभी के लिए प्लीज जस्ट अंडरस्टैंड मी, ठीक है? थोड़ा ट्राई टू अंडरस्टैंड व्हाट आई एम ट्राइंग टू से। ओके, सो रिकर्जन होता क्या है? इफ आई एम अप्लाइंग रिकर्जन इनटू समथिंग इट इज कॉलिंग अनदर थिंग्स, तो उनके साथ भी वही सेम काम हो रहा है। लूप मतलब लूप नहीं है एक, बट सेम काम फिर देन सेम काम, ऐसे ऐसे करके सिमिलर वर्क विल हैपन विद एवरी सिंगल थिंग। सो देन दिस इन इटसेल्फ is a smaller sub problem. What recursion focuses on, recursion में we solve a problem by solving something and then a sub problem. ठीक है, ओके। अब मजा आएगा आपको, अब यू विल बी इंटरेस्टेड अ लॉट। व्हाट इफ आई वांट टू predict the in order output? Again all the nodes will be printed, but in which order? इन ऑर्डर क्या होता है, चलिए देखते हैं. इन ऑर्डर इज व्हाट लेफ्ट node or root, whatever, right? So basically the thing is in between the calls. Pre-order, it is before the calls. So you do not have to actually memorize this thing. It is obvious. There are only three things: the node itself, left and right. So in between left and right. Now please understand what will be the output. I will tell you the output. No, it is not divide and conquer approach exactly. इधर देखिए. The output will be something like this. What I told you is left node right. Now initially this is what left. This is the node 1 and this is right. Getting it? Please understand. Initially this is left, this is node, this is right. I want what is happening in order is the left part is printed first, then the node, then right. Please understand. So the entire this was left, node, right. Left in itself is a tree, node is the node, right is a tree. So first of all, I will print, please understand, 20, 40, 50 bunch. I am calling this as a bunch. ठीक है? Collection or maybe. ठीक है? Then I will print 10, then I will print 30, 60, 70 wala subtree. Please understand. Left, node, right. Now let me correct this thing, please. This is not the exact output. I'm saying this in itself is what? A tree. This in itself is what? A tree. This tree. In this tree, in order will happen again. It will happen, sorry, happen again. So what is left? This is left. This is node. This is right, beta. So left node right, left node right, left node right. In this bunch, what is left? 40, 20, 50. So 40, 20, 50. This is as it is. In 30, 60, 70, what will happen is left node right. So 60, 30, 70. Please tell me in the chat if you are understanding this. This is how it works. Okay, tree is getting easy, yes. Okay. Now let's talk about post order. पोस्ट ऑर्डर की बातें करते हैं. पोस्ट ऑर्डर. In post order, it is again very simple. There are only two things, left and right. So post means after left and right. So left, right, and the node. ठीक है? This is post order. LRN. ठीक है? This thing is after the calls. Again, we have three things. What will be the output? What will be the output? It is very simple. It is very simple. This is left. This is node. This is right. As of now, this is left, complete this is node, and this is the right thing. Okay, a node in itself is a subtree. It is a very small subtree with one value. Okay, so this is left entire thing, this is node, this is right. So again I said कि पहले left है फिर right है फिर node है. So the bunch of left was 20, 40, 50. Write it in any random order, it does not matter. So left, then 30, 60, 70 is the right subtree, and then our node. Getting it? So the order will be something like this. Now again, ये चीज अपने आप में और ये चीज अपने आप में एक subtree है. These are subtrees. Let's talk about this and apply left right node on this. Left right node. So in this subtree, left is 40, right is 50, node is 20. So 40, 50, 20. Please understand. Left, right, node in this particular subtree, left right node, left right node. So पहले ये फिर ये फिर ये. Please understand. Please understand. In this subtree, left right node. So 60, 70, 30 and 10. So this particular output will be the post order. Same tree, pre-order, in order, post order. Tell me in the chats if it is crystal clear to you. These three orders are known as depth first search, DFS. A lot of students are giving the right answer. That is very nice. Yes, it is getting a lot easy while visualizing at the same time. Okay. So this visualizing is actually much important. ठीक है, आई हैव दिस रेड पेन विद मी, अनफॉर्चुनेटली यू गाइस मे बी यू हैव इट, इफ नॉट देन आई वुड सजेस्ट कीपिंग सम हाइलाइटर्स विद यू, थोड़ा इजी रहता है। ओके, वैसे इट विल बी वेरी क्लियर बिकॉज आई मेड द यूज ऑफ दिस पर्टिकुलर थिंग एंड you guys are now able to understand it. Yes, visualize are much better than actually reading a left right node. Now you have आपको ये रट्टा नहीं मारना है लेफ्ट राइट नोड या फिर लेफ्ट नोड राइट या फिर नोड लेफ्ट राइट, जस्ट रिमेंबर यू हैव लेफ्ट राइट एंड देन द नोड। सो प्री मीन्स पहले लेफ्ट एंड राइट के, इन मीन्स इन बिटवीन लेफ्ट एंड राइट, पोस्ट मीन्स आफ्टर, पोस्टपोन पोस्ट होना, राइट? ओके, yes. So this is very simple: pre-order, in-order, and post-order. Sir, we can implement this without recursion in code. Technically, yes, but I will tell you much later. Okay? It is much difficult to understand without recursion. Recursion is very simple. Okay? Didn't catch your name. Okay, so my name is Raghav Garg. Okay? Yes. ठीक है, ठीक है. Let's do some questions. ठीक है. अब you have understood how to traverse the tree, print the values of tree in different values. Let's do some questions. The first question is, first of all, there is a brain teaser for you, or I should say some homeworks. Sir, some homeworks for you. Homeworks for you. I am making two trees. You have to actually, without coding, using pen and paper, you have to write the pre-order, in-order, and post-order of these two trees. I'm making some trees, okay? I'm making some trees. Let me see how many of you will get it right. This is your homework. हाँ, this is your homework. This is your homework. ठीक है? This is your homework. Or there is one more question. So one, two. Just give me 1 second. क्लास छोड़ के तो नहीं जा रहे ना यार? हम्म, क्लास छोड़ के तो नहीं जा रहे? So I have written some values and these are two trees, two different trees. You have to tell the pre, in, and post orders. Pre, in, and post orders of these two trees. Okay, can you do it? ठीक है. So you have to do it. This is your homework, not right now. अगर कोई बहुत जल्दी बता सकता है तो you can tell me right now as well, but this is your homework. ठीक है, take these as tasks. Now let us move and by the way, you will get the screenshot of this as well. You can take the screenshot right now. You can take the screenshot right now. You will get these notes, but still I would suggest you can take the screenshots. Okay. Yes, you have class tomorrow as well. कल भी आओगे सब? ठीक है. Screenshot you can take. I will get you the notes in the description link or maybe the GFG website of 160 page. शेयर योर लिंक्डइन. अरे यार सोशल्स पे आप राघव गर्ग लिखोगे आ जाएगा. सो राघव गर्ग लिंक्डइन पे आ जाएगा और गीकी राघव. ठीक है, राघव से पहले गीकी. आपको बाकी सोशल्स में ये मिल जाएगा. इनफैक्ट लिंक्डइन पे भी शायद यही @ है. एनीवेज, ठीक है. नहीं, आई एम नॉट एन SD @Airbnb. कोई और राघव होगा वो. ठीक है, चलिए इधर आते हैं, कुछ क्वेश्चंस को सॉल्व करते हैं यार. कुछ क्वेश्चंस को सॉल्व करते हैं यार. ठीक है, इनको हटा देता हूँ, नोट कर लो यार ये सब. ठीक है, नोट कर लेते हैं. ये लिखे रहने देते हैं, नाम ही तो है अपना. ठीक है, अब कुछ क्वेश्चन सॉल्व करते हैं. अगर आपसे पूछा जाए, आई एम राइटिंग 2 क्वेश्चन. सबसे पहले साइज ऑफ ट्री. सो व्हाट इज साइज ऑफ ट्री? एक्चुअली साइज इज नंबर ऑफ nodes in the tree. Now what you will be given as question is, please understand. Let me go to the coding screen. बहुत टाइम से अब इधर है. I hope this is visible to you. In questions, you are generally not given the main function, right? You will not be given, this will be hidden. देखो, मैंने इसको छुपा दिया. This will be hidden and you will be मतलब your task will be to complete a function. Now tell me, if I give you the node of the tree, just the root of the tree, no matter what the size of the tree is, the size of the tree is simple, it is the number of nodes of the tree. ठीक है. So the no number of level height is not equal to height, Dheeraj. I will talk about it in just a minute, but please listen to me first. ठीक है. What I am saying is कि if I am given only the root of the tree, can I not tell the number of nodes in the tree? If I can print all the nodes in the tree, please see, I can print these nodes. If it was a bigger tree, for example, I made these connections as well. Love bhai. I made 2 more nodes as connections. So I am printing 9 nodes now. So if I can print all the nodes, can I not tell the number of nodes using the root node? I can. I can. I can. Arya is saying counters can be used. I am saying an easier method can be used. And Shobit is absolutely correct. ठीक है. Now let me tell you the beauty of recursion. Please let me come in the iPad screen. Now let me tell you the beauty of recursion. मजा आ जाएगा इसमें आपको. ठीक है, this will be very very interesting. This is the beauty of recursion. Let it be any tree. For example, I can have a standard tree as well. I can have absolutely any tree with me. Example number 1, the standard tree. थोड़ा सा इसको चेंज कर देते हैं. For example, this is my tree having 1 2 3 4 5 6 nodes. This is missing, this is a null. My choice, right? So I have 6 nodes. प्लीज टेल मी. मैंने ना आपको बहुत ही प्यारा एक कॉन्सेप्ट समझाया था. आई टोल्ड यू वन कॉन्सेप्ट विच वॉज द मोस्ट इंपॉर्टेंट कॉन्सेप्ट. दिस वॉज द कॉन्सेप्ट. 3 parts in every binary tree. This is the left subtree, this is the right subtree, and this is the node, or maybe you can call it the root. We have root, left subtree, and right subtree. Please remember, this is the key concept of tree questions. We have root, we have root, we have left subtree, we have right subtree. So please tell me, can I not say that the number of nodes or the size of the tree, it is the same thing, is equal to the number of nodes in root, the number of nodes in left subtree, plus the number of nodes in right subtree. So 1 plus number of nodes here plus number of nodes here, please understand, is equal to 1 plus number of nodes in left subtree LST plus number of nodes in right subtree RST. Am I not correct? Please tell me in the chat. Please tell me in the chat. Is it correct? Yes. 1 plus number of nodes in the left subtree and right subtree. Now there comes the interesting part. I am saying that recursion will do all the work. Recursion will tell me the number of nodes in the left subtree. Recursion will tell me the number of nodes in the right subtree. Also, the most important part of a tree is to understand that when I talk, for example, this is A, this is B, this node is C, this is D, this is E, this is F. For example, when I say that size of A, please understand, it does not mean that size of this node, which is 1. No, no, no. Size of A means the tree whose root node is A, the entire tree with root A, the size of this tree. ठीक है, the size of A गायब हो गया, एक सेकेंड क्या, अरे हाँ, ठीक है. When I say size B, it means where is B? It means the size of this tree with B as a root. Please understand, please understand. Very important. ठीक है. Yes, I know it is dinner time. वो 10-11 हो गया है. चलो, so these are last 4 questions which I am doing. Very simple questions, 2 minute each. ठीक है, 2 minute each. And even my device is saying that it has to go for dinner. That is why it is doing some हरकतें. अबे फिर चले गया यार, क्या हो रहा है ये? एनीवेज, स्क्रीन गॉन मैड सेंसेशंस. हाँ भाई, स्क्रीन में सेंसेशंस हो रही है. अब मत जाइयो. हाँ, यही रहे, यही रुक. ठीक है. सो समझ आ गया है सबको यार? ट्री में कितने नोड्स होते हैं? 1 प्लस लेफ्ट सब ट्री में नोड्स प्लस राइट सब ट्री में नोड्स. द नंबर ऑफ नोड्स इन द टोटल ट्री इज 1 प्लस नंबर ऑफ नोड्स इन एनएसटी एंड नंबर ऑफ नोड्स इन राइट सब ट्री. सो मैं अब कहता हूं कि रिकर्जन यार मेरे को अपने आप ही सारा काम करके दे देगा. मैं कहता हूं साइज ऑफ, फॉर एग्जांपल, अ रूट इज 1 प्लस साइज ऑफ रूट डॉट लेफ्ट. मुझे पता है अभी दिख नहीं रहा होगा, नहीं दिख रहा है. साइज ऑफ रूट डॉट राइट. आई हैव टू जस्ट रिटर्न दिस. कोड लिखता हूँ, 2 लाइन का होगा. चलो, ये अपने आप ही हट गया, भाड़ में जाए ये. अब मैं शेयर करूंगा अपनी स्क्रीन. ठीक है, कोड कोड दिखाता हूँ. कुछ नहीं करना, रिकर्जन पे भरोसा. यू हैव टू यू हैव टू हैव फेथ इन रिकर्जन. ठीक है. अब लेट अस टॉक अबाउट दिस ट्री ओनली. फर्स्ट ऑफ ऑल, लेट्स फॉरगेट अबाउट दीज 2 nodes. So this was our original OG tree with 7 nodes. So its size should be equal to 7. Let us make a function. जैसे ये print function है ना यार, ऐसा ही एक function बनाते हैं. Please tell me what will be the return type of this function. Can you tell me? Chat. Int. कितना तो आता है ना? Because I need a number. I'm not printing anything. I need a number that I will print. So int size will print the number of nodes in the tree. It will again accept the root node. The root node can tell everything. This is a one-liner code. I repeat, this is a one-liner code. One-liner code. कैसे? Size of the tree is nothing but I will return 1 plus size of the left subtree. This is the left subtree, beta. This is the left subtree plus size of the राइट सब ट्री. बस सर इतना ही था? हाँ, बस इतना. हाँ, डन. यस, बस. हाँ, कुछ कमी है इसमें? प्लीज टेल मी इन द चैट्स व्हाट आई एम मिसिंग. बेस केस. बट ये सही है बाकी. सो वन लाइनर कोड. द बेस केस इज if the root is null, if the root is null, I will return anda 0. Why? Because null is nothing. And also, please understand, let me walk you through one more time in the iPad. Please understand. इधर देखिए. If For example, I have to calculate the size of this, size D. So this is a small tree, the size is 1. So will I cover this in the base case? No, I need not. Technically speaking, the size of this tree is 1 plus number of nodes in the left subtree plus number of nodes in the right subtree. Whenever I reach null, it is 0. It is giving 0 answer, right? This is what is happening. Okay? This is what is happening. Now I have already written the code. I have already written the code. Let me see the code first and then the screen. This is the code. Is it visible? Two-liner code. Okay, this is a two-liner code, right? Now let us actually understand via recursion what is happening. Okay, via recursion what is happening. Let us take a feel of the recursion. If the sensations are not present in the screen. ठीक है, थोड़ा सा सेंसेशन हटा देते हैं स्क्रीन का, इधर आ जाते हैं. आजा भाई, चलो. दिख रही है स्क्रीन? कैन यू सी? नहीं, आई डोंट थिंक इनबिल्ट होना भी चाहिए. दो लाइनर कोड है यार. अरशद, इसको भी इनबिल्ट लोगे तुम? ठीक है, इधर देखिए प्लीज. मेंटेन योर फोकस हेयर. दिस इज अ वेरी इंपॉर्टेंट पॉइंट. सम ऑफ द स्टूडेंट्स आर ऑलरेडी अवे एंड दे आर मिसिंग दिस थिंग. एनीवेज, तो हम इधर है, ए पे है. सुनो, अब साइज कैसे निकलता है मैं बताता हूँ. ए बी सी डी हटाते हैं. ए बी सी डी हटाते हैं. मैं कहता हूँ ट्री का साइज यानी कि इसका साइज, ये क्या रिटर्न करेगा अभी बताता हूँ. अभी बताता हूँ. ये कहता है यार मेरा साइज कितना है, पता नहीं यार, आई डोंट नो. बट आई नो कि माई साइज इज 1 प्लस माई लेफ्ट सब ट्री का साइज प्लस माई राइट सब ट्री का साइज. वॉट ही डज इज, ये बोलता है अरे लेफ्ट भाई साहब आंसर बताओ. कहता है चलो ठीक है बताता हूँ, रुको रुको. सो 10 कॉल्स 20. 20 बोलता है मुझे भी नहीं पता अपना आंसर, लेफ्ट से पूछता हूँ. 40 बोलता है मुझे भी नहीं पता अपना आंसर, लेफ्ट राइट से पूछता हूँ. 40 पूछता है लेफ्ट से, वो था नल. तो वो कहता है यार ये लो मैं 0 दे रहा हूँ, मेरा कंट्रीब्यूशन 0 है. फिर 40 अपने राइट से पूछता है. वो कहता है ये लो मेरा कंट्रीब्यूशन 0 है. 40 कहता है, 40 सेज दैट ओके माय लेफ्ट सब ट्री इज गिविंग मी 0, राइट सब ट्री इज गिविंग मी 0, 0 contributions. माय ओन कंट्रीब्यूशन इज 1. सो आई विल गिव 21. So 40 says that 20, my size is 1. So 20 says, okay, your size is 1. What about my right subtree? Let me ask him. Again, same thing happens. Okay. So 50 gives what? I'm not making more arrows, or shall I make more arrows? Okay, so 20 asks 50. 50 says, okay, I don't know. Let me ask my nulls. My null says that 0 contributions. My own contribution is 1. So 20 are actually my size is 1. Now 20 says, okay, my left subtree size is 1, my right subtree size is 1. My size is my own contribution 1 plus 1 plus 1, 3. So it says, okay, my size is 3. Now 10 says, okay, left से मेरे पास 3 आया, I got 3. From right, 10 will actually get 2. It will get 2 and then it will say 3 plus 2 plus 1. I will give my answer 6 to the main function. ठीक है, आजा, हट गया. प्लीज, शेयर ही नहीं हो रहा है यार. हो गया. ठीक है, इधर आए. अरे यार, हुआ हुआ, हो गया हो गया. ठीक है. आई थिंक आपको समझ आ रहा होगा, मैंने थोड़ा स्किप कर दिया बेटा, मैंने यहाँ का थोड़ा स्किप कर दिया है. अब ये दिख भी नहीं रहा है एंड इट इज लाइक फ्रस्ट्रेटिंग. अब मैं टच, अब तो मैंने कुछ भी नहीं किया. हो सकता है यार ये थोड़ा जूम को हो रहा है, थोड़ा अजीब सा हो रहा है. इट इज सेइंग टू कंप्लीट द सेशन. ओके, सो व्हाट आई विल डू इज कि इन द नेक्स्ट सेशन ऑफ टुमारो सेशन we will start with the next questions. But I think I will give you some homeworks. Yes, my LinkedIn is Raghav Garg, you can search it. Anyways, please यहाँ इधर आओ. ठीक है. You understood the diagram, right? And the code, the diagram and the code. Now I will recommend कि please do something कि make different diagrams and do the dry run yourself in your notebook. Okay? In the notebook. बहुत सारे लोग आ रहे हैं, उनमें से कौन से राघव सर? अरे तुम इंस्टाग्राम पे आ जाओ, गीकी राघव पे, वहां बता दूंगा लिंक्डइन. ठीक है. एनीवेज, चलिए इधर आ जाओ प्लीज, इस पे ध्यान दो ना, लिंक्डइन पिंक्डइन देखे जाएगा, आप पहले पढ़ाई पे ध्यान दो। ठीक है, कनेक्ट होना बाद में की बात है। तो ये जैसे एक कोड है। अब मैं आपसे एक सवाल पूछता हूँ, योर होमवर्क is to actually find the maximum value in a tree. We will solve it tomorrow. So you are given the root of the tree, that's it. Not these values. Like its maximum is 70, it can be anything. You have to find the maximum, if the return type will be int. You have to find the maximum value in the tree. And again, the hint is two-liner code. One-liner code, one is base case. Okay, it is very simple. I will make you understand in the next class tomorrow, but it is your homework. Please find the maximum value in a tree. Very, very simple. The class will be started at 8 p.m. tomorrow as well. Same timings. माफ कर देना मेरे को मेरी अंग्रेजी के लिए आज, ठीक है? It is very difficult for me to take classes in English, but I am taking classes in English. ठीक है? Okay. Hmm. Please tell me if the class was really good or not. Please give me your reviews. I want every single student to comment right now and tell me if you like the content or not. Tell me on my socials as well, on my Insta. You can tell me at the rate Geeky Raghav. If the session was good, please do not ask me for job referrals or anything else. ठीक है? Okay, so bye. कल मिलते हैं, tomorrow. ठीक है? Good night.